the angle is not. So that's what I set out to do. From the flat Earth perspective, the globe Earth angle to Pikes Peak should be 2 degrees 17 arc minutes under ideal conditions prior to being corrected for refraction. And is that if the Earth is a globe, the angle cannot be 2 degree 31 arc minute flat Earth angle. So that's what I was about to demonstrate. These two websites listed at the top of this slide are both really good resources for calculating the distance between an observer and a peak. And both of these sites also calculate the initial bearing from the observer and the final bearing from the peak. The NOAA site expresses the final bearing as a back azimuth, and that needs to be added to 180 degrees for westerly bearings, or subtracted from 180 degrees for easterly bearings. The distance is useful for calculating the expected elevation of the peak, like I did on the prior slide. And despite these minor differences between the two sites, the final bearing is going to be useful later on from whichever site you got the final bearing on from. The first website is also really nice because it gives an extremely detailed explanation of the math that's involved in making these calculations. In NOAA's case, they're resting on their laurels, so they just give you the results and they don't tell you how they got them. So for that reason, I actually prefer the movable types website. Some people argue NOAA is more accurate. So bearing, which is also known as azimuth, will soon become a very important topic of discussion. If it were possible to see from the tip of Africa to Victoria, Australia, the globe illustrates why the compass bearing would change along that green straight line of sight between those 2 points. And then my man Shane has some really good tutorials for those of you who may not understand why both flat and globe Earth use exactly the same coordinate system. And I recommend starting with his link on the bottom left for anybody who needs tutorials to understand why flat Earth and globe Earth use the same coordinate system. Well, my first attempt to, is a question there, or was that a hot mic?
No, I was just letting you know that the flat Earth cannot have the same coordinate system because on a flat Earth, the Tropic of Capricorn is twice the size of the Tropic of Cancer.
Well, if I'd recommend, I really recommend going and view Shane's website because it explains, yes, indeed, we both do use exactly the same coordinate system. In fact, later on, I'll actually be demonstrating that on a spreadsheet. We are using the same coordinate system, so that's something you'll need to brush up on. My first attempt to measure Pikes Peak employed a very well-used antique David White 8300 level transit type of theodolite, the kind shown in this picture. That antique theodolite is only accurate to 5 arc minutes, so the 2 degree 31 arc minute flat Earth prediction rounds to 2 degrees 30 arc minutes, and the 2 degree 17 arc minute globe Earth prediction rounds to 2 degrees 15 minutes. My old theodolite is more than sufficiently accurate to easily distinguish between those two predictions. And to my surprise, my very first measurement was 2 degrees 30 arc minutes. But the big question is, was my measurement accurate? Well, I quickly learned it didn't matter whether or not my measurement was accurate because all terrestrial theodolite measurements may be skewed by refraction. So next, to bypass the problem of refraction, and this happened 5 months ago, I proposed using mountain peaks as the horizontal crosshair of a celestial theodolite. The concept consists of just recording what time, what peak occludes what star. And in that way, it doesn't matter where the peak or the star appeared to be, or what path the starlight took before it disappeared. The only thing that matters is that it was the peak that occluded the starlight. It is then a very simple matter of looking up the elevation of the star in an astronomy tool to determine the true elevation of the star, and that needs to be done with atmospheric correction off because you want to know where the star really is. And I'll now actually demonstrate that. So this time-lapse video was 2 minutes of viewing the Pikes Peak Visitor Center, 50.7 kilometers west of my house. A jet flew from south to north about midway through the video, so you'll see a streak going across there. But this was my first relatively good video of a mountain peak occluding a star. The photo on the right is the video frame 1 second before the Pikes Peak Visitor Center occluded the star 39 Aquarii at 6:27 p.m. Mountain Standard Time on January 31st. A white rectangle on the left side of that peak is the lights in the observation room of the visitor center. And then you'll also see a light dusting of snow on the peak that's visible through the starlight from the clear sky above the peak. Then I went to Stellarium to look it up. The light gray circle is the Stellarium view of a 15 arc-minute radius around the approximate midpoint of the ground level of the Pikes Peak Visitor Center. The dotted red line is the expected 2 degrees 31 arc-minute elevation of 39 Aquarii. So it was about 2 arc-minutes higher than expected. And at that time, um, this being my first actual good measurement, I presumed that 15 arc seconds of that error was because the visitor center hadn't included the star yet, and another 15 arc seconds was due to the height of the visitor center above the ground. And so I thought the actual deviation from the expected measurement was about 1.5 arc minute. And it wasn't until 2 weeks ago that I realized most of the deviation actually resulted from a minor error in Stellarium's calculation of the azimuth and elevation. And now we can discuss that. Um, this diagram, uh, which I lifted from Science Telescope magazine, depicts the astronomical view of the celestial sphere. These equations convert the right ascension and declination angles into azimuth and elevation, and they look deceptively simple, and yet they provide a nearly exact match to Stellarium's angles. Notice that the local sidereal time angle is just the Greenwich mean sidereal time angle plus the longitude of the peak or the observer. And if you want to try calculating this yourself, you'll find that website to be in the lower left corner. You'll find that website to be invaluable. And you will probably get the closest match to Stellarium if you use the local true sidereal time angle. A slight miscalculation of the local hour angle impacts both the elevation and the azimuth, which you can kind of see if you look at the terms of these equations. And that makes the azimuth a valuable indicator to detect when your astronomy tool is miscalculating the location of the star. So as I was analyzing star data, there was a huge anomaly at North Peak. And while I was investigating that anomaly, I actually discovered that Stellarium miscalculated the azimuth for that peak, which meant that it was also miscalculating the elevations of all the stars that were allegedly being occluded by that peak. Now, fortunately, that's an easy error to correct due to the direct impact of timing on azimuth, which you can also see that from these equations. And the fix consists of just adjusting the timing so the azimuth aligns with the final bearing of whatever was your favorite bearing tool. Um, whether you use NOAA or you use movable types, either one, just align the bearing with that tool. So eventually I began plotting this on graphs, and this is one of my first graphs after I had discovered and fixed incorrect azimuths at North Peak and Blinn Mountain. So I adjusted their timing to manually correct their azimuths, and this was my first graph of the raw results comparing flat Earth predictions to globe Earth predictions. And that big dip you see at North Peak resulted from the fact that the globe Earth predictions said the occluded stars were hundreds of meters below the peak due to the alleged curvature of the Earth at that extreme distance. The cyan line on top shows how much globe Earth measurements deviated from the globe Earth predicted angles with atmospheric corrections turned on. So you can see they're consistently too high. The green line on the bottom shows how much globe Earth measurements deviated from the globe Earth's predicted angles with atmospheric correction turned off. And you can see those are consistently too low. And finally, the red line in the middle shows how little flat Earth measurements deviate from the flat Earth predicted altitudes with atmospheric correction off. So it's a little above the zero line, a little below, but way closer than either of the globe Earth predictions. And despite the deviations, it was clear that the celestial theodolite measurements were closer for flat Earth predictions than for globe Earth predictions. And this graph made me wonder what would happen if I corrected the azimuths for all the mountain peaks. So I did that. And so here I added a column to my spreadsheet to offset the timing to correctly align all of the bearings to the movable types website. I determined what was correct by just putting a ruler against the video screen to measure where the peak was and where each star occlusion occurred relative to the peak. And then I could calculate how much offset that was. And then finally, I just adjusted the timing of every star in each video for the average offset that I was measuring in the source video. And that produced this much cleaner graph where it became immediately obvious that the globe Earth measurements with atmospheric correction off were actually flat Earth measurements minus twice the d squared over 2r drop predicted for globe Earth. And the reason that occurred is because the globe Earth prediction first has to account for the alleged d squared over 2r drop at the peak. And then the globe Earth prediction also needs to account for a second d squared over 2r drop as it rotates away from the peak, across the alleged curvature of the globe, through the tangent point, and over to the observer's location. So that's what's happening there. And then with that revelation, it became possible to actually use the globe Earth prediction from the observer's location with atmospheric correction off as the calibration standard for everything else. And what I did for this graph was to adjust the timing of each individual globe Earth measurement so that it perfectly matched the globe Earth prediction. And by perfecting the green line, it compensated each occlusion for any real refraction that might have occurred, any uneven terrain, any bearing errors, etc. Literally, I just assumed globe Earth is perfect and used it as the standard for everything else. And when I copied those timing offsets to the other spreadsheet tabs, it cleaned up all the measurements for both flat Earth and globe Earth, as you see on this graph. And I can go back and forth, and you can see how there's just not much difference between these two. And then I now have a brand new graph. This is the most recent version of my spreadsheet. And this version uses the right ascension and declination equations from slide 11 to automatically compute azimuth and elevation without the need to look up any of that data using Stellarium. And actually, I can go back and forth between those two, and you see there's virtually no difference between Stellarium and this new graph. And this spreadsheet very closely emulates Stellarium, including all of the mistakes I've seen from Stellarium so far. I've seen quite a few little, they're mostly minor, but this is duplicating Stellarium's mistakes. And it uses G.G. Bennett's refraction equation. And so basically what's happening is this spreadsheet uses the equations on slide 11 to transform a flat Earth into the illusion of a globe. And here's a diagram using Pikes Peak as an example of what's going on. And using any version of my spreadsheet, it's clear that the elevations of the occluded stars match the red flat Earth predictions and do not match the cyan or green globe Earth predictions. And it was necessary to refute those flat Earth predictions to refute the null hypothesis. So the celestial theodolite failed to refute the null hypothesis that the Earth is flat, and it therefore falsifies the hypothesis that the Earth is a globe. And that situation is the blue text at the intersection of true and not rejected on this chart. So in other words, the null hypothesis that Earth is flat is true and therefore not rejected. Consequently, the hypothesis that the Earth is a globe is incorrect. And at this point, any doctoral student would have just exchanged the hypotheses and then go on to successfully defend their newly discovered correct hypothesis. So that's the end of my um, pre-presentation. Um, and we can go on now to questions or any discussion about the spreadsheet or other topics.
Could you actually show the spreadsheet, Dr. Mike, just so people understand where the graphs are coming from?
Yeah, I'll have to. I shared the uh, presentation rather than the screen, so I'll have to unshare, and then
Yeah, that's okay.
and I am doing that now.
I just want people to see exactly how that graph came about and what's the information represented there. So it might be helpful for those who haven't seen it yet.
Okay, and I'm going there. I'm
Yep.
pedaling as
And
fast as I can.
if everybody just doesn't do anything and just waits in the stream, it'll pop up again. No rush, Dr. Mike.
Jesse, my man.
Hello.
How you doing, brother?
Oh, pretty good. How are you doing?
Lovely.
All right, and
You have
there
questions for
we
Dr.
should have the
Mike?
share.
Oh, yeah.
There we go.
So I've added a couple buttons on this. I'm gonna reposition this a little bit. So I can turn the GG Bennett refraction off, and then you see that it collapses down into the green line, which is the stellarium view of refraction with atmospheric correction off. So atmospheric correction off, atmospheric correction on. And then I've also got one where I can turn off the timing offsets. So this is what the graph looks like if you just take the raw data, ignoring the fact that the bearings are incorrect. And then when you turn the timing correction back on, it just cleans everything up. And these are relatively minor timing corrections. As I recall, they were just a few arc minutes off. So it 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 may seem like a huge deviation, but toggling back and forth, you can kind of see it's really not that different. There's just a little cleanup when you fix the bearings.
Yeah, if you go back to that peak atmospheric off spreadsheet on your bottom left.
There you go.
There we go. I just want folks to see this is where those graphs are coming from, what data is being represented. And J, the column J is actually your timing offset, right? And it's just
Right.
Okay, gotcha.
So you can see in most cases it's a few seconds. When you get down to when you scroll down to North Peak, which is the big outlier, then it's in just a minute. And even at the Blinn Mountain site, it's over a minute of corrections. But that's, and if you look at the, let me see here in the azimuth column, let me click on this. This column, the this is since this is from the peak viewpoint, this is the final bearing. So movable type says the final bearing should be 109.5205 for Blinn Mountain, and the actual uh, numbers were coming in at 109.34, 110.2, 109.34, 109.51, 109.54, and
That's what that column represents right next to it. Got it.
Right, that's
Yeah.
and let me see. This is with timing offset on. Let me turn that off and go back to there. now you can see without that timing correction, it's like 30, 40 arc minutes off, and that's what's causing the big deviations on the graph. When you've
And
got the bearings that far off from reality, and you can see that also on North Peak, which was the worst.
and
It,
real quick,
it
Dr. Mike, um, you're referencing Ruhif's confirmed angle, right? In terms of applying the offset correction,
Sorry.
the timing correction.
What's my confirmed angle?
When you sent professional surveyors
I
to
didn't
his
send
location.
professional surveys.
Oh,
He means the idealized globe calculation, or for Pikes Peak. Like if you had no refraction and you looked at it and measured it, it would be 217. That's what he means.
Right, but with
okay,
refraction at
so
219.
Sorry, 1 second. Let me turn you up, Ruhiv. What was that?
With refraction, it's
Mike?
219, right?
Right. But like the raw would be 217 or something, right?
Yeah.
okay. That's what I was referring to. Sorry, I meant like you're in agreement with that, the 217 and the 219 with
Yes.
refraction.
Right,
Okay, cool.
right. Yep. And in fact, you can go back to some old presentations, and those are the numbers that are mentioned from the very beginning.
Mhm.
That those were the expected globe Earth elevations, and this makes it incredibly easy to just see that in action. Um, And in the past, I was unable to do this because all this has to be it was a manual process looking up in Stellarium. Now that's automatic and built into the spreadsheet. This is incredibly easy to do. So that's the uh, 2 degree 4 arc minute uncorrected, the 2 degree 19 arc minute corrected, and the 2 degree 33 or so arc minute measured. And then with timing offsets, it makes it perfect. 2 degrees, 2 degrees 04 for the uncorrected, 2 degrees 17 for the, actually, I think that's 2 degrees 19 for the corrected. And then 2 degrees 31 arc minutes for the flat Earth prediction.
Awesome.
I'm confused as to what exactly. How are you predicting the location for a celestial object on a flat Earth versus a globe Earth? Because that's what you're comparing, right?
Yeah, you got rise over run, and then you got with the corrective celestial and terrestrial refraction, right?
Right. So that's all here in the right ascension and declination, and whether you interpret that as globe Earth or flat Earth, and you can look at the calculations and basically um, uh, we're calculating the height calculation is the same whether it's globe Earth or a flat Earth. It's different with peak ATM off versus observer ATM on versus observer ATM off, and then the graph is just plotting these results. So literally difference between flat Earth and globe Earth is whether that d squared over 2r drop is factored in or not, and whether GG Bennett or whatever refraction correction they used is added on top of that. So one of the things this graph can do is I can actually when I turn off GG Bennett's, you can see that um, the Bennett calculation is just built on top of this no atmospheric correction, and no atmospheric correction is actually minus d squared over 2r. It's just that much below the globe Earth calculated value. Turn on the
Nope.
atmospheric correction, and all of a sudden it's slightly above the zero line, or in the case of North Peak, where you allegedly can't even see the star yet, it's way below it.
And
But
you're
as you can see
applying.
from the red,
Oh, sorry. Go ahead.
oh yeah, so as you can see from the red line, the flat Earth prediction has no deviation. It's spot on what trigonometry would calculate the rise of that peak over the distance. Take the tangent of that, multiplied by the distance, and you've got the predicted elevation of the peak. Now subtract the actual elevation of the peak, and there's no deviation. So with the green line, we're doing something very similar to globe Earth. It's you take the globe Earth prediction, um, subtract the height of the peak from that, and what do you know? You get a second d squared over 2r drop, and that's because it's from the observer location, not from the peak. And same thing when you add the correction on there, you're just adding that to the green line, and now it's overshooting the globe Earth predicted elevation from the peak, which it in flat Earth terms, the globe Earth prediction is the peak will be lower than what it appeared to be lower than what it actually is by d squared over 2r. So this is just doing those straightforward uh, calculations. These are all available in these columns, so you can see the calculated peak altitude. Here is the actual altitude minus the predicted, and this column is showing you the deviation. And this is with timing corrections on. If I turn those timing corrections off, this is just raw deviations.
And those numbers represent meters, correct?
Correct. Everything in this spreadsheet is meters and
Arc minutes.
meters for distance. Yeah, meters and I tried in most cases to show both degrees with decimals and degrees with DMS. So whichever method somebody prefers, they can use. But on all of these, there's a and that column's mislabeled. It says flat delta altitude. That should say globe delta altitude there.
Nice.
So I'll fix that right now while I'm seeing it.
Boom.
I
guys
probably
saw
made that
nothing.
same. Yep, I probably made that same mistake here. I did because I just copied and pasted the
From the previous.
the
Yeah.
yep.
No, I think
Literally
the
the
visual
only
graph is awesome, Dr. Mike. It really it's helpful to kind of understand the differences between all the peaks and the different predictions.
Yeah,
and the only difference between ATM off and ATM on is ATM on adds the GG Bennett
Refraction formula.
refraction. Yep.
I like how the graph like swiftly, succinctly refutes the nonsense claim that, oh, look, it works for concave and globe when I manipulate the process, completely change the flat Earth side, and then cherry pick my data. It's like, well, no, the actual data and the depiction of the graph doesn't allow for any of that. As you can see with the actual data, no, the flat Earth is closest to zero every single time, and the globe Earth is wrong both with and without refraction. So,
Hey, I got a question when it's my turn.
Shoot.
Oh, thank you. So I'm trying to understand what the actual measurement is. I mean, sure, we time an occlusion, but any errors in that don't affect the deviation of the red line in the graph, right? In
Sorry
other
for
words,
the pause there.
oh, sure.
I lost my mic button. Yes, they do. So if I turn any timing corrections off, you can see that red line is deviating. And when you actually go to the tab on the graph, let me see how
That's
do I
not what
get
I
that
meant.
back. Okay.
So let's say there had been a cloud layer that caused the star to occlude 3 minutes earlier than it should have, but you didn't know there was a cloud layer, and you put in that initial time, and then followed your procedure. Would that still give a result that matched the flat Earth? Because
And
when
the answer is no, it would not. In fact, that's what this red line shooting way high at North Peak is indicating. Um, that shot way high. Initially, I thought it might have been because earlier in the day we saw a cloud, and I thought maybe cloud was occluding it. But it turns out this is that area where stellarium and my emulation of stellarium is miscalculating the bearing. So it's off to the left, and it's measuring that star before the peak has occluded it because of its timing error. Um, and so you can see when the star's too high, it shows too high. So that happened initially with Pikes Peak, with Blodgett Peak and Cheyenne Mountain. You can see they were both measuring too low. Mount Rosa was almost spot on, and I realized after the fact the reason it was spot on is if you look at the videos of Mount Rosa, Mount Rosa kind of looks like a triangle. It's got a very pointy peak, and I found so few stars that were occluded right by that peak that guaranteed that the final bearing was exactly right. And then with Blue Mountain, you can see it's a little low. North Peak is way high, and then Lynn Mountain is way low again. So if you just take those incorrect bearings wherever they fall, that's what you get when you fix those incorrect bearings. This is what you get. No deviation at all on the red line that shows how much measurements deviate from flat Earth predictions. You can see on the green line, the uncorrected globe Earth prediction is low by exactly d squared over 2r, which is what you would expect it to be. And then when you add G.G. Bennett's refraction correction on it, you get this cyan line at the top.
I mean,
But-
this. Okay, go ahead.
But I don't think you answered my question. Maybe you didn't understand it.
You
What
asked
is
him if there was a cloud layer in the way, and that you might have misplaced where the mountain peak was and mistaked it for a cloud, right?
Is that what he said?
well?
Yes.
So
Yep.
Yep.
So I did answer your question. This is what happens if the measurement is way too high. It shows that it's way too high. This is an accurate representation of where that star actually is, where it was measured to be. And once you correct for bearing errors, this is an accurate indication of where that star is uh, when you have the bearing correctly calculated.
let me try again.
All right.
Yeah, I'm not communicating. How is the J value derived? Is it a measurement, or is it is it a measurement? Is the J
It's
value
similar
based on?
to the question I asked to Dr. Mike about the timing correction. Like, what was the referent?
Yeah, if you go to your your observer tabs or whatever, just go to the observer tabs.
Yeah, observer ATM off.
So the J tab for the timing offset. So that graph might look kind of confusing, but the 0 is the flat Earth prediction, right? And then the timing correction is the difference from the idealized globe. So this timing correction here is when the star is at the idealized globe position, and this is just the difference in that for comparison. So what he's saying is when you align everything, globe, atmosphere, off, on, and flat Earth, it fixes it all. And why it wouldn't do that if there was no relationship there. So that column, right, is the timing difference between what Stellarium says and what was measured. Right, we're not throwing out measurements or anything. We're calibrating.
Yeah, he's applying that timing correction to all three predictions.
Right, but he applies a unique timing correction to each star, even if they're hitting the same mountain at about the same elevation. So
he's asking what's the difference between you putting in, for example, Dr. Mike, like let's just say TYC 5826, like you see how you put 9 for J, and then why not put 9 for let's just say the next star? So he wants to understand the difference in the J values, correct, Jesse? I see him at it.
well, I'm asking how that time offset is derived. Is it based on a measurement or based on a prediction?
It's based on where the star is at that angle with using stellarium when it's actually at that angle, and it's just the difference in when it was measured versus when it's when stellarium says it's there.
Well, how is it measured if stellarium reported the incorrect time?
What exactly is your contention by saying when is it measured? We're literally comparing when they say the star is physically there at that angle, at the idealized angle. Your line of questioning seems ill-formed.
Well,
so let me try this again, because I've had this discussion many times with Jesse, and Jesse was actually he's been arguing. He thinks the azimuth has no bearing, pun intended, but the azimuth does have a bearing, and in the case of that 9-second correction for TCY, the bearing for that star was 2956 and 2 arc seconds. Well, that's where the star actually is. But if you don't have that timing correction, where it shows up is wrong graph. Sorry about that. It shows up at 249, 54, and 36 arc seconds, which is way off from where that star has to be occluded by the peak, which is sitting there at 249, 53, 12. Oops, excuse me. The peak is sitting at 249, 28, 15. So this column is showing the offset of each star from the peak. This is the offset without timing corrections. And then when you turn the timing corrections on, this is where those stars sit with the timing correction. So going back to that one, you can see there's quite a difference in the bearing. And what the timing correction is doing, if you go back to the RA and DEC conversions into azimuth and elevation, is just adjusting the timing so that the elevation and azimuth corrections are correct, specifically so that the azimuth is correct. Because if that star hit to the right of the peak, it needs a bearing that's on the right of the peak being this number right here. If it's to the left of the peak, it needs a bearing that's to the left of the peak. I don't know if I'll find any of those easily here.
But
there's one. Oh no, sorry, my mistake.
I think we're getting ahead of my question, or behind it or something. I mean, so the claim is that stellarium was off in timing by over 3 minutes in the case of Greenhorn Mountain. And that was known because the altitude angle indicated by stellarium when set to the actual time of occlusion, the altitude angle was not what it should have been. Am I, and this is just a yes or no, I don't need 15 minutes of response. Is that a yes or no?
No, you've got that wrong. No.
Okay. So how did you determine that there was anything wrong with stellarium in the case of Greenhorn Mountain? Because you added over 3 minutes of time shift, right?
Right. It took about 3 minutes of time shift to put the azimuth to the correct value. so let me see, North Peak right here. The azimuth, and let me see, do we have correction on or off? We have correction on. Let's turn it off. Okay, so this column shows the azimuth with timing
The timing
corrections off.
correction off, right?
Right, timing correction is off. And when you take a ruler, put it on your screen, and measure where those stars occlude relative to where the peak is, they're all occluding to the left of the peak. Here's where the peak is, and they're all occluding to the left of the peak.
Which peak?
Because
North.
North Peak.
Are you aware that North Peak was not in your frame?
I'm well aware of that. In fact, I've stated that over and over again. It is off to the right of the screen, but it's just off to the right. It's not very far off to the right. And Greenhorn Mountains is exclusively on the left side of that video, and virtually none of the stars are being occluded by Greenhorn Mountain. So you'll see that
Well,
the video is mislabeled Greenhorn. Well, it's not mislabeled. It is correct. Greenhorn Mountain is there.
could I share my
And
screen? Because I've done some checking. I've determined that the main Greenhorn Mountain peak was in field on the left. And I also determined that I-7 did occlude just to the left of the main Greenhorn peak.
so there
So,
you misstated it. It could not have possibly occluded to the left of Greenhorn Peak. So go ahead and share your screen.
okay. Give me
Even
1 second.
so, is your point of contention that his timing correction is off? Let's just say the timing correction is not even applied. The graph still shows what the graph shows. So, like, what's your actual contention? Or are you
Well, it
just
shows-
pointing out a typo for Dr. Mike to correct? Or
No, without the timing correction, Greenhorn Mountain resoundingly shows 2,000 extra feet, 2,000 feet higher than the published height, which of course would be catching a lot of airplanes because that's a lot of extra height. So,
And it does that whether you're using a flat Earth measurement over a globe Earth measurement. I think that's where your statement is kind of misleading. That's what ultimately led me to realize, oh, of course, everything is reading too high, whether you're using flat Earth measurement or globe Earth measurement, because Stellarium is giving us the wrong values, and it's giving us the wrong values specifically because it dramatically miscalculated the azimuth bearing by over 3 minutes.
so can you see my screen share, Doctor?
give
Not
him a
yet. Oh,
second.
there it goes. There it is.
Okay. Can you see this faint star that I'm kind of moving my mouse around on the left bottom of the screen?
I see that.
That is I-7, and it occluded right there. This is the main peak of Greenhorn Mountain right here, and that's where I-7 occluded. So that should not have been 3 minutes time off from the peak, right? When in other words, the azimuth is very close. So you shouldn't have had to move it 3 minutes plus to get it to line up to the peak, right? Or to compensate for its azimuth.
And I didn't. So you'll notice that I don't even include I-7 on the list because it was occluded by Greenhorn Mountain rather than North Peak, and I only included the stars that were actually occluded by North Peak that I could verify were occluded by North Peak.
Oh, okay. So I-7's not even on the spreadsheet. All right. Any other point of
That's
contention,
correct.
Jesse?
Well,
Yeah.
that makes sense.
Yes. No. I-7 you should put I-7 on your spreadsheet
Why?
because it did occlude. It visibly occluded very close to a known point peak on the mountain, which would demonstrate that the azimuth was not off like you thought. Now let me show you how much.
So actually, Jesse, if I could correct you right now, because you can see that star is occluding way to the left of the peak. So the azimuth is off, and it's also several hundred meters low.
Well, the peak point for the actual peak of
Looks like it goes
Greenhorn
higher
Mountain
to
is
the
right
right,
here.
right? What's that red line to the right, Jesse?
What red line to right?
You outlined Greenhorn Mountain, so obviously that's not the peak, right? The peak
Okay.
would be more to the right, right near the right side of the screen, because that doesn't look like the peak. That looks like the peak. There you go.
No, that's a bump between about halfway between the Greenhorn Peak and North Peak. Now let me change my screen share here.
So Jesse has repeatedly says it's halfway between, but North Peak is just off the edge of the right of the screen.
Let me show
Oh.
you. Let me show you. It's more
Wow.
than just off. Here, hold on. Let
What a
me bring up
snivelly thing to
Stellarium.
do, huh?
All right, are you seeing Stellarium?
Yep.
Or was that my password list? Okay. All right, so I've set up Stellarium to have the field of view frame box for the sea star. And you can see this is, if I zoom out a little here, and I've also imported the horizon line, or the skyline from Peak Finder. So you can see this is Greenhorn Mountain here. North Peak is clear over here. So you can see when I zoom in, I hope these little lines show up. North Peak is literally, so you were looking at stars right here and thinking they were on North Peak, but they're literally halfway between North Peak and South Peak, I guess, if you want to call it that. So, I mean, check into it. And I got one more thing to back this up here. Let me change my screen share. If I can find it. Oh, yeah.
Not gonna lie, that's pretty cool, Jesse. You got the sea star frame right there.
I had to
Pretty
Google how to
interesting.
do it, but there's other people that do it.
Yes.
It's actually
What's
pretty
up,
sick.
boys?
All right.
It's a
Well,
piezo.
But I mean, the point doesn't refute any of the data. He's just trying to eke it about something else already, right? Trying to
That's
give
okay.
it the last hope
Let's see where
to hang
Jesse
on.
goes with it. He's the only one that's trying.
Well, I know, but
Hey,
then
where are we at in the
all the people
conversation?
like Ruhif will then hop on this and then build some nonsense, non sequitur trophy on top of the nonsense foundation, and then that's all they
I-
have. Oh, what's up, Ruhif?
Let's
I
not
didn't know you
count
were
our
here.
My
chickens
question's
before
pretty
they
simple.
hatch.
Hey, Alan, can you give me like a 30-second catch up to where we're at? Is that possible? Just real quick, short and sweet.
Yeah, so we started with going over how J was derived, and now we've segued on to a misalignment of stars or whatever with respect to Greenhorn Mountain and or North Peak. So it definitely appears to be Greenhorn. But
Okay.
I'm not sure where we're going with this.
We're on a Jesse rabbit hole. Come on, Jesse.
So
Let's go.
so to be clear, the J value was derived because Mike used Stellarium to see where on a glob the star is supposed to intersect the mountain at whatever time, and then he went and measured it physically, and it was a different time, so he took the difference, and that's the J value in seconds.
Yeah, to set the calibration for the spreadsheet. Yeah.
Okay. All right.
So you can see, yeah. So what I'm working with is, my question is, how does the J value get derived? Half the time we say, oh, it got derived by making the, adjusting the timing till Stellarium matched the ideal globe angle or something at the observer location. Then when I try to look into, dig into that, is that legitimate? Then it gets switched to, no, it's derived from the azimuth correction. So now we're addressing the azimuth correction, which was, in my opinion, not valid because North Peak was not where he had assumed it to be. So here I've lined up from his video to Google Earth, showing Greenhorn itself and where I-7 occluded. and where IPUP occluded, and you can literally tell it clips this little hill, and then it happens to be going at the same angle, so it gets like half brightness, and it slides all the way down this hillside, and then finally occludes in this little valley. So,
okay, can I stop you real quick just for clarification? Dr. Mike, did you use I7 or IPUP in your spreadsheet?
I did use IPUP, and if
Okay.
you'll notice, how I corrected the azimuth of IPUP versus what Stellarium reported it, you'll see that azimuth is the issue there.
Go ahead and keep your screen shared, Dr. Mike. We can hop back and forth between them, just so we can have some back and forth, if that's okay with you. Yeah. All right. So let's go look at IPUB, Jesse.
okay.
All right. There it is. All right. Go ahead and just keep it there, Dr. Mike, for now, and we'll go back to Jesse to see what is the problem with IPUP.
So the question is, how much did you adjust IPUP? And did you think that that bump that it occluded on was actually North Peak, or did you think that that was about halfway between North Peak and South Peak?
So I've repeatedly said, and I'll say it again, North Peak is off to the right. It's beyond the edge of the screen. So we know that everything attributed to North Peak is actually a little to the left of North Peak. And you have your opinion of what bump is where, and but I prefer to go by the azimuth. So if you look at the raw, uncorrected measurements for IPUP, Stellarium reported that occlusion at 200 degrees, almost 45 arc minutes, which is four arc minutes beyond the edge of the video, and yet we clearly see it's on the video.
Right. Yeah, 4 arc minutes. What is that? How many seconds is that? 32 seconds? No. 16 seconds. In real time, right? Something like that?
Yeah, 1 arc minute translates to 4 real life seconds.
Right. So if it's off by 4 arc minutes, it's off by 16 seconds in the video. Is that correct, Dr. Mike? Just about.
So that's the good back of the napkin estimation.
Back of the napkin estimate, right.
Yeah, but my real point is Jesse's red video frame ends at 200 degrees 41 arc minutes, and this is setting 4 additional arc minutes beyond the right of that. So just by looking at the data, Stellarium is wrong about that. They can't both be right.
Gotcha.
So are you disagreeing that IPUP set roughly halfway between North Peak and South Peak?
Yeah. If you look at where Greenhorn Mountain is versus where North Peak is, you'll see that it's set that it was occluded much closer to North Peak, and it was actually on the North Peak plateau. When you look at a satellite photo of that, satellite photos, you'll see and topographical maps, you'll see that that's a fairly flat plateau there. So it hit close to the proper plateau. If you could go back to that diagram you just had there, one thing I was going to point out is those two peaks are 1.5 kilometer apart. So that you might misconceive that that's an enormous distance there, but those peaks are pretty close to each other.
Well, can you see my screen share now?
Yeah, go ahead and zoom in, Jesse.
Well, I lose perspective if I zoom in, but
Yeah, use your dorsal. You better.
this is that little bump that IPOP set over. North Peak is all the way over here on the right. It literally was halfway between North Peak and South Peak that IPOP set. So what I'm saying is that if you went in and applied the same time correction to I7, which set on I7, which set over here on the left, that you would find that it placed it way in the wrong place. If you actually figure out the actual the latitude and longitude of the point of occlusion and put that into the NOAA azimuth calculator, you'll find that it matches stellarium very closely. And the reason you thought that the azimuth was way off on IPOP is because you thought it was a lot closer to the peak of I7 than it, or the peak of North Peak than it really was. So can you do that?
And so actually, I'll repeat my assertion again. It is much closer to North Peak, and perspective tricks notwithstanding, when you look at the bearing of North Peak, it's 47 arc minutes. That frame ends at 41 arc minutes. It's thick arc minutes beyond the right edge of the screen, and the screen frame is 44 arc minutes wide. So it's just barely off to the right of the screen, despite your perspective tricks.
Yeah. Let's Jesse, go back to the video where you had the two red lines illustrating Green Mountain, and you had IPUP on the left side. It was your YouTube video, real quick.
Let me just see if what he's saying is true here. If I'm wrong, I'm wrong. I'm willing to admit it. I'm drawing a line.
Just for reference to what he's talking about in terms of the azimuth being different. Just real quick.
Okay, so I can come back to this afterwards?
Yeah, come back to it after. Just real quick.
Which one did you want?
Just pop up your YouTube video again.
The video? Was there diagrams, or was it a video?
Nope, your video. The one with two red lines on it.
All right, stand by.
Dr. Mike, you have that. You have the azimuth for North Peak right there, right? 200 degrees, 47 arc minutes, 52 arc seconds.
That's correct.
Okay. So this azimuth you have right here, Jesse, in this video, 200 degrees, 41 arc minutes, 24 arc seconds. And do you see?
Oh, those are just approximate. I did this video a long time ago, and before I had figured out.
Yeah, but you're using this video to make your point.
Just a second. Well, I'm ignore those. This profile tells us where on the mountain it hit. Because look, we can see, here's your frame of view. Here's that little bump. That little bump on the right is not. And I matched it up to the video. Never mind the azimuth indications. I matched it up. So we know where those stars occluded. And that's my only point with the video.
We'll go back to the video real quick. Yeah. So where's IPUP?
Right here. It's kind of faint, but it's
That's
visible.
I7.
Oh yeah, I7. I'm sorry, I7.
I said, where's IPUP?
Oh, what time was IPUP? I think maybe this is it coming in hot here. No, that's not it. It'll come. What was the time on IPUP?
Let's see, Dr. Mike, the time.
2208.
22:08:21. Ah, so that's a little farther away.
So
keep going. Let's go to 22.
I'm in -7. But but he might be 2 for this. 22:00 what?
You in Mountain Time, Dr. Mike? on your spreadsheet?
I'm in Mountain Time, so the spreadsheet
Mountain Time.
says it was -6, so that would be 2108, 21.
Let me check my spreadsheet. I got it in my -07.
If it's -07, then just add
It'd
an
be
hour.
2108.
Yeah,
It'd be
2108.
Okay. Let's see. Yeah.
So let's go back to video a little bit. 2108.
I've got IPOP listed as 22. Wait, wrong peak. No, North Peak. Oh, I'm looking at his spreadsheet. Let me look at my spreadsheet.
Well, that's 2208, 21 Mountain Time. Your time, right? Pacific time would be 2108, 21.
All right, just give me 1 second.
I just want to make sure we're all on the same page. That's all.
Yeah.
Okay. So if we could scroll back your video to 2108, then it'll match his spreadsheet.
All right, let's see. 21.
Yep, just about there. Okay. Now in this,
Okay, there. See. I'm gonna go off push to talk because I can't hold the push to talk and frame jog at the same time. It won't work. Hold on.
all right. So
All right, can you hear me?
all right, so let's identify IPUP in this still.
Yes, we can, Jesse.
Yes.
Yep.
There's this beautiful 3-star pattern right here. So let me go to Stellarium and identify that pattern. So we're at 2108. 2108.
Can I ask what the point of all this is? Like, y'all are spending so much time trying to figure out one measurement of one star.
Doesn't
There's like
matter.
20
It's
on the
to
spreadsheet.
kick up enough
Jesse
mud where
is-
people can
I
ostensibly
mean-
say there's a defense when
But
there's not. That's what it is.
Jesse's claiming that the timing correction is invalid
Why?
All right, let me.
because he's saying that this one particular star, IPUP, which was supposed to be occluded by North Peak, which has an azimuth of 200 degrees, 47 arc minutes, and something arc seconds. I'm not looking at the graph, but and then in the video of actually showing when IPUP is getting occluded, Jesse is claiming that it's not actually being occluded by that peak, so the azimuth would be off. Right, Jesse?
Oh, say that again.
Is that your steel man?
I'm sorry. I was about to change streams. I wasn't listening. Okay, can you see my Stellarium?
Yep.
So these 3 stars here. This is this one.
And there's IPUP.
And there's IPOP. So
There's
this,
IPUP.
This 3-star
And what-
pattern matches up perfectly.
And that's at that time. All right. So on your video, you're saying, okay.
So this is
Yeah.
There's no question that this was the frame.
Yeah. No, I got you. So, okay. So the timing. So you're saying it's in between the peaks. So the azimuth wouldn't be off?
It would be an altitude difference between wherever it is versus North Peak, and
Yes.
also the angle change between those two things, which it would create a difference. It'd be hard to quantify how small or big it would be. You'd have to do it manually, but there'd be some difference, I think, is his point.
Why don't we do this? Why don't we
But like, what's your overall contention though, Jesse?
Yeah, can you spell it out? I'm trying to figure it out.
Is it
Make
just,
an argument.
Is it just IPUP that you have a problem with?
Well, I want to know what the problem is. Like, what is the conclusion of the point you're attempting to make? Let's just make it coherent for everyone. 'Cause I don't think anyone knows yet, other than maybe you. Like, you're like 30 minutes deep in this, and we still don't know what the point is.
Well,
So can you make the point and then show us how what you're doing now supports the point? Like we need to know the point first, or we're just like lost in the woods with you being the only person with a flashlight.
That's a good idea. That's a good idea. So you showed the evidence of your argument. What is the argument?
Yes, thank you for pointing that out for people that have only been here for the last 20 minutes.
so the argument is that maybe correcting IPUP, because it was assumed to have hit over here when on the North Peak, when in reality it was about halfway between. Maybe that worked, but that was not a valid correction because it was not anywhere near close to North Peak. So what I'm saying is that if we were to do the same procedure for I-7, which...
He didn't use I-7, though.
Well, but let's say Dr. Mike puts I-7 into his spreadsheet and applies the same correction.
But he didn't, though. Can we use one that he actually did in his spreadsheet? If you want to make this argument?
Hold on. Let him go through his line of logic here.
Okay.
But all of the ones he did, he referenced their azimuth to where he thought North Peak was. So they're all wrong by the same amount because they're all the same, because North Peak was the same, was not where he thought it was. So, Dr. Mike, would you be willing to add I-7 into your spreadsheet and do the same process to it to show that the process is valid? Because we do know, we know where it hit on that mountain, because we can see that it hit just to the left of that left high point, right? I mean, if the method works...
Can you make the point? Like, I still, you're asking questions. Like, we want to know what the point is. We're trying
Make
to get
an
there.
argument.
Using the azimuth is invalid if the peak you're measuring on your screen with your ruler is not where you think it is, because you're not measuring from where you think it is.
So just completely throw it out as totally invalid? Like are you going to make a quantification of how incorrect it is? Because the thing is, Jesse, is like, can you quantify how much of an error there ought to be? Because you can't just say it's completely invalid because it was off a little bit. Like there's an amount of invalidness, right?
Sure. Let's look at I-7.
Well, so your point is that the one of the 26 observations is off?
He's actually arguing that an observation that's not even on the spreadsheet is off, which is kind of a bogus argument.
Yeah, it's weird.
It can't be off because it's not even on the spreadsheet. But that's what Jesse wants to argue. He likes to argue hypotheticals instead of arguing actuals.
Yeah. Could you make the same argument with actual data? So like IPUP is on the spreadsheet. We could talk about IPUP. So like what Piezo said, how off is that particular observation, and what is the timing correction supposed to be rather than what he put on the spreadsheet?
Wouldn't it be a difference based on the altitude difference at that point of the mountain versus that other point of the mountain?
Yes.
Which is going to be like some number of arc seconds different, which converts into seconds difference, which converts into height difference.
Yep.
And then if I could repeat something I said earlier, clearly we can see IPUP being occluded by somewhere in the vicinity, in the rough direction of North Peak. We can argue whether it's halfway there, 3/4 of the way there, whatever. But the point is we can see it clearly occluded by the peak on Jesse's video, 21 hours, 8 minutes, and 21 seconds. And this is on a video where Jesse estimated the right edge of the frame is 200 degrees, 41 arc minutes, and yet Stellarium says that star occluded at 200 degrees, 44 arc minutes. In other words, it's 3 arc minutes beyond the right edge of the screen, and yet we're clearly seeing it horizontally. So we're clearly seeing a disconnect just on Jesse's video alone, which means Jesse has he's estimating what he thinks is the perspective, but he and
Can I address
Stellarium have
that?
a major disagreement about what the perspective is.
So basically, there's a difference horizontally of 3 arc minutes, which is going to make a very minute height differential based because it's still the same ridge line. It's just not the peakity peak of the ridge line. It's ever so slightly below the peakity peak of the ridge line, and that's going to make some ever so slight deviation in what Mike's correction is.
Well,
And
listen.
that's sufficient in your mind to throw the entire method and every observation on that sheet out? Is that what I'm getting from you?
Listen, stop bringing up these azimuth angles. I used Google Earth to approximate those, and Google Earth uses Haversines, I guess, so it doesn't give exact azimuth angles anyway. You need to use Peak Finder or something else. But I used Google Earth to get approximate frame edges just to help people line up their stellarium. That's all those are for. Those are not accurate. But they get you close enough to find the star pattern in stellarium, okay?
Okay.
That's not the point. I've objectively shown using Google Earth that North Peak and South Peak are both on there, and the star that sits in the middle here, it's sitting in the middle. It's not even it's not significantly closer to North Peak than it is to South Peak. So why is it unreasonable of me to ask that we put I7 in the spreadsheet and treat it the same way? Because here's the thing. Let's say we applied the same 3.5 minutes of shift to I7. So there, 2110 is when I7 occluded.
Aren't they different stars?
Yes, but they're occluding at the same, pretty close to the same distance and pretty close to the same height. So.
Hold on a second. Wait. You still haven't said what your contention is, other than there's a slight difference in the timing because it's not exactly at the peakity peak. It's like slightly below it. What's the contention then? Can you spell it out? Because it's been asked you 4 times to spell it out. If you can't clearly spell out your own point, then no one else is going to get it.
To be fair, I'm not a big fan of him myself, but he did say it earlier. He said that if he used the wrong azimuth, then not just that one would be wrong, that all the measurements would be wrong as well, and that it should be rechecked.
All the measurements as in the 3 from that ridge line?
However many were used on that frame.
Jesse.
Uh-huh.
What do you hope to prove through what you're doing right now? Can we skip to what you're hoping to try and prove, and then we can worry about trying to do the proving? Because you're currently trying to do proving, and no one knows what the proving is going towards.
I'm doing disproving.
Whatever you want to call it.
I've disproved the claim that I pop occluded closer, significantly or significantly close to North Peak. I've shown.
Okay, let me ask you a question. At that juncture, it's very close, right?
No, it's not.
In Stellarium, well, hold on. In Stellarium, it shows that the star hits the mountain ridgeline at 44 arc minutes, and North Peak's at 47 arc minutes, right?
Let me look.
Yes.
The occlusion.
That is correct.
What was the occlusion time for? Let's see.
Dr. Mike, if you can go back to your spreadsheet with the timing correction off real quick. Yep. Perfect.
It was 08, right? 8 minutes past.
There you go. Okay.
21:08:21.
21.
Yeah. And there's the azimuth right there on Dr. Mike's spreadsheet, Piezo.
All right, 1 second. So
I just go back and forth on them. Yeah.
Jesse's fixed on a star. What's the azimuth? It's 244 and 42. It's almost 240. It's almost 45 arc minutes.
Right. It's about almost 200. It's 245.
Okay.
201. It's another. So it's another to North Peak, it's 201.09. So that's let's see, that's another 25 arc minutes, right?
But hold on, I thought Dr. Mike was assuming that the North Peak he was using was at 247 according to the spreadsheet.
Yep.
200 right here, right on the right. That's my point. He thought the peak was right here. It's really right here.
I got to go back to your screen. Hold on a second, Jesse. All right, go ahead and show me what you're showing.
Okay, so this right here is 247 right here. So he thought North Peak was right here. It's really over here.
Okay.
Okay. What is the height difference between those 2 points?
I could figure it out. It would take a little while.
That's very relevant because the height difference is going to be converted into an angle difference and a time difference. So, I mean, are we talking about like 1 second of timing difference, 2 seconds of timing difference, a second and a half of timing difference?
Well, we can get that out. But listen, if he thought North Peak was right here at 247, but it was really at 201.09.
So you've repeated a piece of misinformation so often. I feel like it's important to correct it. I do not think the peak is at 247. That's where movable type says it is. And in the case of NOAA, it says it's 2.5 arc minutes different, and I don't remember which way. But there's a 23 arc minute discrepancy between where Stellarium says that star is and where NOAA and movable types say the peak is.
Did you say arc minute or arc second?
Arc minute.
Arc minutes. So just to reiterate, this is not me misjudging where the peak is. It's NOAA and movable types misjudging where the peak is if a mistake is being made. And in any case, the star is 23 arc minutes away from where the peak is, according to Stellarium.
Okay. And is that
so
not
it's a 23 arc minute difference between where the peak is and where the star is actually occluded at. Is that correct, Dr. Mike?
That's correct. And where Jesse's cursor was just now above the star, it was identifying that as 200 degrees 45 arc minutes. So it's saying it was almost dead on top of North Peak. And yet the perspective he's looking at North Peak in is significantly farther to the north. So this is not the correct perspective to be looking at all of this from.
You're saying the observer should be shifted to the left a little bit so that that North Peak lines up closer to the star in terms of azimuth from the observer?
I think he's looking at this from the incorrect bearing.
No, I've got your house put in there.
Well, whatever tool you're using did it wrong then, because clearly that does not agree with NOAA. It doesn't agree with movable types.
Well, but NOAA and movable types both need you to put in.
Yo, real quick here, Jesse. I think we've kind of reached a impasse here on this for the moment. So why don't we?
Well, can he give him
question.
1 second within the next 5
the picture so that he can impose it? Like, let's see the difference.
1 second. Don't talk over me. Within the next 5 minutes here, let's wrap this up and move on to some other stuff.
Other questions.
Me.
Could we do this for the end? Could you send him that picture and then Jesse could just impose it over his screen where he's showing his angulation and his little model, and then here's your actual observation? Because you're asking a direct question: which side of the mountain is the star appearing on? Right.
Well,
So
I think
you're
the best thing to do into the
now
break.
he's talking about other stars and other headlines, but it's still the same question that was proposed to him, and then we've been on an hour discursion. We're still not sure. Like, we had the 3 minutes displaced time. That's the star on this side of the mountain or the other side of the mountain, right? So it is a very big discussion. He wanted to run away from headings because that's where it's all hidden in the map, is in your heading, because you just think you go heading is south, and it's south at every point. And it becomes confusing for these people that don't understand conceptualizations. So I
So,
think it's
Well,
important
hold
to
on,
stay
bro.
on
I
the
think
point. Which side of the mountain?
we
Where's
are.
the missing time?
He just said 5 minutes, bro. Like we're trying to finish it, but this has been going on for like 45 minutes. We haven't got there. That's why he's saying that. But just to be clear, I think one of the most time efficient things that we could do right now is if Jesse can go back for just a second.
Every time I
Just
go to
Solarium.
this, when you want me to go back,
Sorry,
let me go back.
the screen. Yeah. If you see
When
the
I was
screen,
speaking about
hold on a
hold on
second,
real
bro.
time, I
quick
was talking
into the
about
break.
the time on the
Hold on,
map.
bro.
On the map, I wasn't
Bro.
talking about us wasting time. So I just want to make that clear. So
Yeah, I know.
I
I
wasn't
know you're
saying
not
we're
talking.
wasting time. So sorry
Okay, I wasn't
that
saying you were saying that.
I was talking about the other
You,
time in the map.
okay. Jesse, you see where the
Uh-huh.
star is and where the green line is. What we
Uh-huh.
could do right here is we could set a maximum upper bound or error by taking an altitude differential between these 2 points. So the height of where that green line tip hits and where the height of where that star is hitting right now from where you are, whatever error there is, it can't be greater than this. This is going to be the maximum upper bound. So if you can find out what the altitude angle is right there, and then the altitude angle from the other point, and we'll take the trig difference. It looks like you're a little high just by a pixel or two. If you put your mouse tip on right under the green line,
Did you
The
zoom into that?
I'd say
That's about
down.
right.
Oh,
Oh, you could zoom
okay.
in. Yeah.
the
Okay.
Stellarium skyline
Okay.
is not that great, but it helps. It really
Well,
helps.
it'll be consistent with itself, right? So
I
down
don't.
1 pixel. Oh,
It's like
sorry.
there's one point here and there's another point here. It's like it's a real jaggy line. They don't include much data. It's better
Okay,
if
but
you
we're
go
gonna set a maximum bound. So like we're gonna just at least do the trig real quick. Can you zoom back into that right line so we can get a azimuth angle, or
I
sorry,
can't
an
believe we
elevation
made
angle?
this whole thing about these 3 measurements and we have this spreadsheet with 60 other measurements. I guess those are unrefuted for the
Yeah.
whole time. We'll just be granted those and we'll quibble about these 3, which change the mean average 0.2 meters. Okay.
Yeah.
Just to be clear.
Okay. Down 1 pixel. Down another. We need to be like the midpoint of that line, right? Oh,
What?
right. Down 1. Down 1.
What? Do you mind if I switch to Peak Finder, because that's going to
Oh,
be much.
let's use one consistent reference because it's going to be consistent with itself. Whatever the offset is on one
Well,
side,
not
it'll be the same.
necessarily, because it rounds. It chops up the data into
Dude,
line segments that are pretty long, and so a lot of data is lost.
Let's just get a gauge for where we are in the ballpark. I mean, dude, it's not going to change that much. 1407 is going to be like 1 pixel down from there. So 14 minutes and 7 arc seconds. Now can you go to the star?
What's
Back
that?
to the
Oh,
star.
the star.
Yeah.
You want
Right. Yep.
the
Yeah, zoom in
elevation
where the star is.
Yeah, the star is at 1232.9. Oh, 1233 basically.
Okay, 1233 and 1407. So 1 second. 1203 and 1407. Now, what's the
No, I'm
distance to the
sorry.
mountain?
I'm sorry. 0 degrees, 12 minutes, 32 seconds of elevation angle.
1233 and 1407. Sorry. Okay. And then what's the distance to the mountain from observer to peak?
I'd have to look on my
It
spreadsheet or go to
is
Finder.
130,556 meters.
130,556.
Yeah. Well, that's according to Mike's spreadsheet.
I'm going to use Mike's numbers because he got all the NOAA stuff. We're going to use a consistent baseline. Okay. So the opposite over adjacent. So tangent adjacent equals opposite. Okay. So 131,000 what, Theastocles?
It was, sorry, the distance you said?
Yeah.
130,556 meters.
556 times the tangent of, let's see, 14 arc minutes, 7 arc seconds. Okay. One moment. I gotta convert this to degrees.
All right. So thanks, Jesse, for helping us make the spreadsheet more accurate.
By ignoring 97% of the measurements. Thank you.
That's all right. Hey,
just trying to keep it clear on point for the people in the back who may be trying to focus as they muddy the water as much as they can.
Okay.
I do want to hear Ruhiv's question after this.
So we've got
Go ahead.
we got 536 meters up on one side, and then on the other side we've got 1233.
Oh, and Dr. Mike on the graph. No, that's flat delta. Never mind.
Okay, hold on 1 second.
You know, here's something we could do.
I got the math. I got it right here.
All right.
All right. So 476, 60.61, and 536.11.
So less than 100 meters.
So we've got 59.5 meters maximum is like the maximum error that we're looking at. So it's going to be 59.5 meters or less. That's an upper bound for our altitude error. Okay.
We're looking for a heading. We're looking for headings.
Right, but I'm just saying we have a 59 meter differential maximum. That's not necessarily what our actual differential is. We're setting an upper bound on it because we would have to account for like the heading and bearing stuff, which is going to change it as well. But we know in whatever case, the most error that we have here between one point of the star and the other assumed point of the star is 59.5 meters. So if you could turn that into a timing difference, 59 meters into a timing difference. Look at the star. Here's what we could do. Look at the star, Jesse. Can you go backwards in seconds?
Well, that is the differential because they would have placed that 59 meters laterally on a map, but then tell you, but that's actually a vertical curve.
Well, hold on a
it's
second.
Like going in verticality rather than opposed to changing your heading.
Okay, Jesse, can you tick backwards? Can you tick down in the seconds? Yeah, hold. Oh, go back. Wait.
Oh, I see what you're saying.
Until it goes to 1407.
Until what goes to 1407?
The altitude angle of the star.
14. Right. Oh, you had it. Perfect.
So 55. So that's 6 and 20. So we've got a 26-second maximum difference.
Timing difference.
So what was the correction that he made?
196.
Like 3.5 minutes.
So if he went, so the maximum difference would be the difference between 196 and 170 because that's 196 minus 26.
Yep, exactly. Or plus, either way.
Or plus. I think it's minus though, because we went back in time.
So it's still 3 minutes off, Jesse. Just about.
I don't think so. I didn't move that 3 minutes.
3 minutes is crazy in lateral displacement on a map. 3 minutes you're going in the wrong direction. You're going in the wrong direction.
Let me put this into perspective. Let's say I'm just going to back off by 1, 2. Was it 2.5 or 3.5 minutes? I think it was 3.5 minutes.
It was like 3 minutes and 10 seconds.
Okay, there's 3 minutes and 10 seconds. That would have put IPUP all the way over South Peak almost. Was it really over South Peak at the time of occlusion? Or if we go forward 3 minutes, it's, I mean, it's going to disappear under my horizon, but it would literally be off to the right of North Peak, which wasn't even on the camera, so we couldn't have seen it occlude. So
is there a third option that stellarium is just off, and by accounting for that timing offset on the front and back end, he still got the correct result because it still traces the same arc in the sky, regardless of if there's a timing offset? Because what we know is correct, Jesse, regardless of what anybody says. We know that Mike went and recorded this with a camera, and it really happened. So we can sit and argue till the cows come home about what stellarium's time says, but he has it on video.
Okay, y'all said...
Yeah, that's why I wanted to have him put that on video and like have Jesse like display that on overlay it on this simple representation we got. And it's
Well,
like,
it
so
doesn't
we
even
have
need to
an
be
actual
overlaid.
observation. Let's compare it with this little toy model.
That's what we just spent this whole time doing.
That's
So
what we, yeah.
In conclusion, the maximum difference between, the elevation at North Peak and the elevation at this part just to the left of it, the maximum differential would be 26 seconds. He had a 196-second correction, so even if you subtract 26 seconds from that, it's still 170 seconds. And it's all recorded on video, and we physically know that it happened. So where you're going to come up with that 170 seconds from, Jesse, is up to you. But I mean, there's a discrepancy between stellarium and what he observed. That's clear. So if he doesn't correct it, what do you? I mean, it has to be corrected for somehow, right?
Well, I don't find a discrepancy because I say that IPUP
lateral refraction. It's lateral refraction.
Hold on in a break. What are you saying, Jesse?
I'm claiming that I have very strong evidence that... Did my screen change to Google Earth?
Yeah.
Okay.
Yeah.
Thank you. I have very good evidence that IPUP occluded on this little bump here, right there, right in the middle, well, close to the middle. And these 3 lines all go straight to Dr. Heffron's observatory. And if you were to actually take these coordinates of where IPUP actually occluded, instead of the coordinates for North Peak, and then put those into the azimuth calculator, especially the one that doesn't have multiple arc minutes of error due to it not being a true geoidal calculator, then you would find that there was no significant discrepancy in stellarium. That star would be at the claimed azimuth according to the azimuth finder. If you
Just to be clear. Okay.
Yeah, if you use the actual coordinates where the star occluded, then there is no azimuth discrepancy like you're claiming. Go ahead.
So just to be clear, Mike just happened to use the NOAA data set instead of your Google Earth data set and compare it with stellarium, and then add an offset, and he kept that offset across the whole process just so it was consistent, and it came out matching a flat baseline. Are you saying that that's a coincidence for all 20-something stars he measured? Because
No, he was putting the coordinates for North Peak into the azimuth calculator, thinking that North Peak was that little bump that was on the right of the screen, but North Peak wasn't
So
that
if I
little
could,
bump.
I hate to interrupt you, but there again, you are misstating what I did. I told you very clearly, I put a ruler on the screen. I measured the offset from the peak.
From which peak?
Didn't. In this case, I probably did it from Greenhorn Mountain because North Peak was off to the right of the screen where I couldn't see it. But and I don't remember honestly, but you are misstating what I did repeatedly. You're saying it has anything to do with the peak. In all cases, I know what the bearing of the peak is, but I measured the star's offset from that peak. Now, it just so happens that North Peak is almost exactly 1 degree away from Greenhorn Mountain. from the perspective of an observer at my house. So it's really easy to estimate how many arc minutes there are per centimeter on the screen. Um, and I find frequently you tell people I did what you imagine I did without ever consulting me, and I wish you'd stop doing that and stop misstating the facts. It's all about bearing, and your bearings and all of your diagrams, your bearings are wrong. You are not you don't have the same bearings I do, and I don't know if that's Google Earth, if that's NOAA, if that is movable types. But what I personally found is movable types seems to be incredibly accurate, and that's always been my preference. Um, but in any case, um, the problem is on your video you show the video cutting off at 241, and yet the star is at at 241 arc minutes, and
How many
the
times
star
do I
is at
have to say that
244.
that was
What?
just an estimation to help people frame Stellarium?
Jesse, let him finish.
He's strawmanning me.
I'm not strawmanning you. I'm calling you out for repeatedly misstating what I do and trying to convince people I did what you claim I did and not what I actually did. Um, for anybody who's in doubt, you can go back and look at the intro Prezi, and I did that for a reason so that there's no doubt what I did, because I found that Jesse is very good at mangling facts and convincing you somebody did something they didn't do. And so that's why I wanted to do that intro
I'm on now,
Prezi so
champ.
it was clear to everybody exactly what I did.
So to be
Well,
clear, Dr. Mike, just for a quick recap for everybody listening, right? You went and you plotted in or plugged in your location in terms of lat long, and you obtained a bearing to the lat long of the star using a conjunction between stellarium and movable type. And then based on this azimuth angle at your location, you correlated that with the star and the elevation angle at which it should occlude compared to the time it actually did occlude, and the elevation angle that comports with that, and that's how you got the offset J value. So the difference between what it was supposed to occlude at versus what it actually did in your video when you went out and measured it.
that's kind of oops. Oh, sorry, my mic's on. That's kind of close to what I did. What I
Okay.
actually did is I just looked at what movable type says is the bearing to the peak, to the nearest identifiable peak on the video from my house. Um, I can, by using a ruler on the screen, I can positively identify where that peak is. From that point on, I can measure every star that's occluded relative to that peak and find out how many arc minutes off it was. So I just adjusted the timing offset to put that star at the bearing it appeared to be on the video. Now Jesse's using different perspectives. So
What do you
he's
mean by that?
what I
Oh,
mean is that
hold on. That's what I wanted to say. That Jesse, what's actually happening is that you have an actual video. This is, you took it from your perspective. Now we're actually looking through it from different lenses. Jesse's lenses. Oh, well, it was maybe off. I find it peculiar
This guy
that it
sucks,
was
dude.
3 minutes off. And so it is a concept.
Is
Sorry,
he saying stuff? Like, who is that?
I don't know.
Into the break in Jack Daniels.
Well, Jesse is looking at it.
Real quick. We've been through this. So the conclusion is that doesn't amount to much, or what? Because I'm ready to. We're moving on here.
Yeah. So
this just sounds like Jesse trying to discredit the doctor. That's all.
yeah. So
Yeah,
Dr. Mike had
desperate.
a 196 second correction for his J value, his J column value, and then we calculated what the maximum error would have been based on the elevation that the North Peak was versus where the star occluded from Jesse's perspective, and it was 26 seconds max. So we just grant that as a max and subtract 26 from 196 and get 170. There's still a 170-second correction. You can make a separate argument on a separate day and talk about where you think that comes from, blah 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 blah. But the point is that the reason that there is a correction in the first place is there are outside variables, including refraction, compression, and all other effects. And as long as you maintain a consistent offset on the front end and on the back end of your measurement from the observer to the mountain and from the mountain to the star, you keep it consistent across the whole thing, then you can still force your line and see whether that line agrees with a flat baseline, a glob baseline without atmosphere, and a glob baseline with atmosphere. And that's what Dr. Mike has done. And it
then
doesn't
if I could,
change anything.
oh, sorry for interrupting. If I could add one more thing, I made my corrections, make the globe Earth predictions absolutely perfect, using them as the gold standard for everything else. And when the globe Earth predictions are perfect, lo and behold, that makes the flat Earth predictions perfect. And if you go to the intro Prezi, you'll see why that is. Near the end, I actually gave a slide that gives how you derive all of the globe Earth angles from the flat Earth angles. And literally, that is what Stellarium is doing. They apparently internally have a flat Earth model, and from that, they wrap it around the globe with their sines and cosines. And you can examine the spreadsheet and the intro Prezi to see exactly how they did that, because I'm using those exact equations that I gave on slide 11 to convert right ascension and declination to as and L. And then toward the end, I don't remember which slide is where I show you how theta sub f, theta sub r, and theta sub g are all derived from flat Earth calculations. So the entire globe Earth illusion
Mike, you've got
is
a fucking
sines and
degree in computer
cosines.
science, right?
I do.
I have two quick
You must
questions.
know that's bullshit then.
Why do you
Hey,
say that?
Ruhiv, why is it that his spreadsheet plotted all the data, and yet after doing this, the FE baseline is within almost every point within like a meter or two?
Yeah,
And
for
then the glob
43
baseline.
separate measurements, and you guys are within 150 to 200 every time. It's just
To be brutally honest, the last hour I've been playing Balatro, paying barely any attention because it's all
Probably because
bullshit.
Jesse was talking and rambling about one star the
yeah,
whole
it was
time.
pretty bad.
So you don't actually have a contention, Ruhiv? You're just saying, no.
No, I do.
Yeah,
I do
he's
have a
just coming in saying, nah, you guys need to be smarter. I didn't pay attention to nothing.
Yeah, it's
Thanks,
crazy,
Rob.
dude.
Right, I do have a contention.
Lewis, do you at
right?
least want someone to catch you up, to what's been said the last 5-10 minutes, or do you want to just keep engaging as if you do know what's been
I've
said
got
for the last 5
two
No,
minutes?
quick
I have a
sounds like-
contention. Would you like me to give you my contention?
If it's good faith, yeah.
Okay. When you guys say that it doesn't match the globe, are you making the globe prediction based on the celestial theodolite stuff?
Dr. Mike, did you quite understand that question?
I did
Where does
not
your globe
understand that
prediction come
question.
from? Okay.
The angle
What
that
is
it's
your
supposed to be,
globe
Ruhiv.
prediction?
Yeah.
What is
so
your globe predicted angle for Pikes Peak?
it's on his spreadsheet, but
Yeah, let's go to the
comes
spreadsheet,
from-
Dr. Mike.
it comes from, well, it's like 217 for the mountain and some change, and then you guys like adjust that and refract it to 219, I think.
Correct. That's our prediction. Yes.
Okay, so
okay.
All right, so that's what it shows in the spreadsheet.
Okay. So are there
Any
any
other contention?
So
are
he's
there any
got atmosphere off at
observations?
217. He's got atmosphere on at 219, and he's got FE at 231.
Yep. Cool. And he actually measured it, or is it your brother-in-law
There
that
you go.
measured it at 218?
See,
What?
you're trying to change it back to what it was 4 months ago, Ruhiv. Very
No,
strange.
I'm making a point here. Mike, did your
What is
brother-in-law
your
measure
point?
it to 218?
He's asking about him pointing a theodolite at the mountain and getting
Yes.
an
Yeah, it was
the
218, right?
parent angle.
Yeah.
Oh,
You're
really?
So the,
confusing a
the
lot.
question,
You're confusing a lot of facts in your mind, Ruhif. I think what you misunderstood is my brother-in-law did not make any measurements. My brother-in-law lent me a theodolite that was 5 times more accurate than my theodolite and much newer. And I made measurements from that from my front yard. But that's all kind of beside the point.
Well, you got
no,
217
it
though,
is my
right?
point.
Right,
No,
Doctor
you got
Mike?
218, I think it was. Yeah, but that's beside the point.
Okay.
It matched the glow prediction for the mountain. So my question is, are there any occlusion timings that disagree with the glow prediction? Remember that
Yeah,
we
there's
Yes.
don't
like
use
30
the
of
celestial.
them.
At
Listen,
Pikes
haven't
Peak.
finished. Haven't finished. We don't
Okay.
use the bullshit celestial theodolite method, right? We just use distance, drop, refraction. Done.
And that's the
Yo,
So
point of the whole entire thing, Ruhif, because apparent mountains don't block physical or don't perform physical blockage of stars.
Well,
And
I
so
made a
what
video yesterday. Maybe you should catch up.
you
Alan,
acting
did you
like
want
you
to
can
say
just go
something?
point a theodolite at a mountain and that settles it shows that you're not even
Yes.
like ready to talk about any of this.
No. I want to know if there is an occlusion timing that
Yes, Pikes
disagrees
Peak.
with a non-straw man, non-bullshit glow prediction. Does that exist?
Do you remember 4 months ago when you said it was just a complete coincidence that the angles lined up with
Yes.
FE?
Yeah,
And that was
I
when
showed it in my video.
we only had one mountain though. Now we have what, 46 stars?
Yeah. Have you seen my
So
video from yesterday? I showed
is
you.
it 46 disconnected, interconnected coincidences all working in unison to
Yeah.
give an illusion?
Both Jesse and I have reverse engineered what distance and delta height will give you a good result for the celestial theodolite, and which combination of distance and delta height will give you a shit result for the celestial theodolite.
You're not trying
This was 2 updates ago, bro. You're 2 updates behind.
Right. But my question still stands. Is there a observation that contradicts the globe prediction?
Yes, I just said it 3
Okay, show it.
times.
Which one?
It's on his spreadsheet.
Yo,
His whole entire spreadsheet.
the whole entire presentation while you were playing a game or whatever, you missed everything. So unless
Yeah.
you have something new to discuss, we're gonna move on to the next person. That's
Right. So
like
you
actually
can't show me
contributed
one that
nothing.
contradicts the globe. Correct?
Yeah, the
You
whole
can't show me one that
presentation
contradicts
was
the globe.
1 second, dog. The whole presentation was measurements that contradict the globe once the instrument is calibrated.
Show me one.
You calling it bullshit, not liking it or whatever, that's not an argument. So we're
No.
gonna move on.
You can straw man the globe prediction. That's fine. But show me a measurement that contradicts the actual globe prediction.
Well, how would you correct the math that we use?
This is wild, all this rhetoric, man. He's like, I wasn't here, I was
you're
playing
deflecting.
a game. Show me.
Keep deflecting, Peso.
Bro.
An
You want to talk
hour-long
about
presentation.
deflecting? 1 second. Yo, you want to talk about a deflecting? Deflecting
Oh,
is
come on, fire up,
not
Alan.
paying attention
Fire
to
up.
this whole thing, coming in on that back end and arguing something that's 2 months old, bro. That's a
Fire
huge
up, Alan.
deflection.
I want to hear
So
some fake
you're done
outrage
now.
from Alan.
You have nothing else to contribute here.
Give me some
why
fake
are you
outrage.
so
Come on.
mad? Why are you so mad, Ruhif?
Hold on a second.
No, he's actually done. That's it. What's the next question? Move on. That's insane.
I mean, it's not good faith to do that, obviously. He's just doing that to get on your nerves on purpose. He's being rude.
So, Jesse, do you agree with Dr. Mike's spreadsheet that shows the globe angle prediction with atmosphere turned on and off? Do you agree with those?
I haven't really looked into the atmosphere on, but I've looked a bit into the atmosphere off. So can you go to that, Dr. Mike? Because that is actually one of my 2 questions that I still have on my list.
And y'all haven't got to that? Y'all sat here and looked at him pull up a star in Stellarium for 45 minutes?
I tried to stop it, to be honest, but I was alone.
Well, I came in and I was here for
That's
like
all right,
25 minutes of it. But
it's all good. We'll just keep going.
All right. So
All right.
Where is this ideal globe prediction?
Dr. Mike?
Click that cell so I can see the formula. Please. Thank you. Okay, that's
Go to the angle, Dr. Mike.
yeah, that's not the prediction. That's the
Uh,
calculation. There's go up one, I think. Up two. Go to I think it's is that it? No, go to
should be Q, right?
I'm not sure. I'm more familiar with the previous spreadsheet because this one just came out like the night before or the day of. I don't remember.
I think this is what you're looking for, Jesse.
Which is the one?
It is V5, which is the globe Earth predicted height rise, over F6, which is the at end globe Earth predicted distance. And
Okay, let's
this
see.
takes the arc tangent of that and expresses it as degrees,
So
which is 2 degrees, 3 arc minutes, and 32 arc
Okay, so
seconds.
F6 is distance. Okay, and what was the other one? Click that one you had with the formula again. Thanks. Okay, and so V5 is V5. Okay, click on V5 for me.
And there you
All
go.
right. Oh, that's what I'm after. Thank you. So, what exactly is this?
This is the height of the mountain minus
Okay.
the height of the observer minus 2 times d squared over 2r.
Okay, and what is that supposed to represent? That does not represent the drop from horizontal on a globe Earth. What is that supposed to represent?
So I explained this in the intro, Prezi. The first d squared over 2r is the actual drop of the mountain height due to a globe Earth. And then the second d squared over 2r drop is from moving from that point across the Earth through the tangent line through the observer's location, which introduces a second d squared over 2r drop. And you'll notice this is the same 2 degrees 4 arc minutes that was confirmed by Ruhif's professional surveyors from my house. So this is an exact match.
He did not send professional surveyors to your house, but go back to
Yeah,
V5.
he claims he did.
No, he doesn't.
He claims he did.
He does not.
He claimed he did.
He did claim that. What do you mean he doesn't?
Openly. So I don't know
He
what
did
this
claim
bickering
that,
shit
and then
is.
he retracted it.
No,
so.
he said he wanted to,
All right,
and then when Dr. Heffron used a real
he claimed
field,
that he could. He never sent them. Let's.
Okay. Let's move on.
All right. So, if you could, please go back to V5 for me. So, if Earth were a ball of the claimed size and there were no atmosphere, and there was a guy holding up a really tall yardstick so that it matched, so it was at eye level to an observer, this far away, whatever the distance is here. 39, no, let's see, where's the distance? 50.7 kilometers. Oops. How high would that yardstick have to be? Would that be
Wait, before we get into a hypothetical, can we just look at the angle and see where the disagreement is on that angle?
We're not doing another 30-minute rabbit trail about lack of measurement. Can we just ask what your question was?
So that angle right there. So do you agree? Hold on. Do you agree with that angle for 39 Aquarii from Mike's house to the star?
Angle to the star? From
That's
where?
what that is.
2,331.
Well, you said that wasn't the globe prediction.
2,331.
Did you have a better math formula you wanted to use, or what?
Yeah. Are you saying that this is not the globe prediction?
That is not the globe prediction.
Okay.
It's not 2,331.
So if that's not the globe prediction, what is?
The globe prediction.
You're saying I can't go on Stellarium right now and get 2,331?
The globe prediction. Well, that's if you put
from the observer to the star, Jesse.
Right. So the globe prediction is the arc tangent of the delta height minus 1 times d squared over 2r, not 2 times. right?
Is that what gives you 331?
Yep.
Mike is showing that that's what that is.
He's getting 2331 with 2 times. You can see that he shows you the formula.
But 2 times is not the formula for globe drop. 1
Well,
times
then
is.
how did he get the right answer with the wrong formula? That doesn't make sense, Jesse.
Oh, it does, because what he's doing, because 2 times globe drop is equal to basically 1 degree per 60 nautical miles. So by subtracting basically 60 nautical miles, or 1 degree per 60 nautical miles at the observer location, then moving stellarium forward to the target locations, he's adding back in that 1 degree per 60 nautical miles.
Hey, hold on. Pause
So
right there. Pause right there. Pause right there. We got that claim. Mike, could you go to this column that you got right there, where you got column Q, and could you go to that formula up there that you were showing originally with the 2? Yeah.
Yep.
Could you go down one?
Well, there it is right there. That's V5. Oh.
Okay. Wait. Yeah. Yeah. Okay. So this formula that you're using to get the angle, right? Is this the 2 times D squared over 2R, or is it in the V column?
The two times D squared over 2R is in the V column.
If you adjust the V column, will it adjust the Q column as well?
It should.
Yes, it will.
Can you go to the V column real quick and change it to 2, from the 2 to the 1? Can you? Yeah.
Certainly.
Yep.
Yeah, let's just do 1. Okay.
Okay.
Now it says 217.
And then compare that to this.
There you go.
See, there's the 217 that would be the unrefracted globe angle. That is the unrefracted, the geometric globe angle to the mountain.
And I think what Jesse doesn't understand is what this column is what stellarium calls the uncorrected globe angle from the observer to the true position of the star.
Right. See, Jesse thought that was for the mountain. See, Jesse, it's 1 times D squared over 2R for the observer to the mountain, but it's 2 times D squared over 2R to the star, because first you have to go to the mountain and do the drop over distance. Then you have to do the coordinate system rotation for that 69 degrees per mile as well. So you're actually doing the same thing twice to get the angle to the star. And they line up at the occlusion point, meaning they have to be the same angle. And so that's what Mike did.
Okay, so we agree that the 331 is not the globe angle to the mountain.
It's the globe angle to the star, which is occluded by the mountain.
Yeah, it's to the star. Which also lines up with stellarium, which says 2 degrees 4 arc minutes from the observer to the star.
And so the point is the star, the whole point of this is to not use any refraction corrections and force a line using nothing but the raw angles with atmosphere off, and if necessary, a symmetrical offset both in front of and behind, or at the front and the back end, however you want to say it. And by doing that, he gets plane trig angles.
And I can explain that on a globe if you are ready, but you might not be ready for that. It's pretty
the
simple.
Part where you just said about him adding it and subtracting it back again was false. He's not adding and subtracting it back again. He's adding it twice.
Okay, so let me ask you.
It doesn't cancel itself out. That's not what's it does not cancel itself out.
Well, I think with about 3 or 4 steps here, I could illustrate to you that this is exactly.
So you basically don't agree. You don't agree with his spreadsheet column Q that shows the unrefracted globe angle. You don't agree with that. From the observer to the star. From the observer to the star.
No, that's wrong. If you're
Stellarium disagrees with you, but you want to keep going back to the globe because you're missing the point of refuting the null hypothesis. The point of the null hypothesis is assume the opposite of what you believe and then prove that that's wrong. Well, what this spreadsheet is doing is showing the opposite of what you believe is correct.
And I have a whole response to the null hypothesis thing too, but there's a key thing that we really need to, until we come to a common understanding of this, we're just gonna not be able to make sense of it. So
you know, Mac did not use any refraction formulas in any of this. So you guys have to say that the star's at 2.3 and the mountain's at 2.17, and the star gets lifted up from 2.3 to 2.17 by refraction, and then incorporate these arbitrary coefficient empirically derived formulas at every different angle band in order to do that. Mike said, forget doing any of that. I'm just going to do 2 times d squared over 2r, and lo and behold, look, I have a flat baseline. Magic.
Crazy.
Weird, huh?
And what's even crazier, bro, is just using that with the GG Bennett formula uniformly swoops up all the like flat earth angles, right? Because when you're doing cell nav and shit, you're not doing like reverse drop calculations or anything like that, right? It's just the old tangent to the horizon, right? Which you guys argue is, you know, tangent on a sphere. And this shows the actual difference between the two.
And the offset, the J offset, what that can do is any leftover deviation, since he accounts for it on the front end and back end, it'll keep it consistent the whole way through. That'll account for all sources of optical deviation. So whether that's refraction, whether that's compression, whether all of it summed together, like the total sum of all optical deviation will be held as a standard offset across the whole measurement, and it produces this chart right here.
well, listen, guys, I'm not being allowed to finish sentences now. So
Okay, bye, Jesse.
if you can't
No,
handle,
please go ahead. Go ahead, Jesse.
Okay, thank you. So, is it true, and this is for Dr. Heffron, because we're all following his lead on this, is it true, Doctor, that when you move the observer location in Stellarium towards the mountain, or towards the star by 60 nautical miles, it raises the altitude angle of the star by 1 degree? Is that true?
That's true when atmospheric correction is off.
Correct, with atmospheric correction off. Okay. So if we take an occlusion timing and we put Stellarium, well, they're very important and they're very simple and they're very on point. So if we take Stellarium and put it at the observer and we adjust the time until the altitude angle of the star equals the flat Earth prediction minus,
oh my god, say it, bro,
1 degree per 60 nautical
think
miles,
quicker,
then move Stellarium forward to the point of occlusion, that will add back in 1 degree per 60 nautical miles, yielding the exact flat Earth prediction. Is that right?
Hang on, did you just go forwards and then backwards and got the same?
Backwards and then forwards, but yes.
Okay.
Could you repeat that, Jesse?
Yeah. So if you take Stellarium and put it at the observer and adjust its time so that the altitude angle indicated for the star is equal to the predicted flat Earth angle minus 1 degree per 60 nautical miles, then you will get an altitude angle that is below the flat Earth predicted angle by 1 degree per 60 nautical miles, right?
You said you're moving from the observer 60 nautical miles toward the peak?
Well, just
he's saying if you take 231 at Pikes Peak and then subtract 69 or 60 miles per degree, basically
1 degree per 60 miles, yeah, for 60 nautical miles.
So take the plane trig angle and then subtract the drop over distance. Now it's a globe angle. Okay, continue.
Okay, when you do that, you get this green line.
Well, So
you see that, Jesse?
But what I'm asking, yeah, I see the green line.
Okay.
But what I'm asking is, if we adjust the time on stellarium so that the altitude angle of the star is equal to the flat Earth predicted angle minus 1 degree per 60 nautical miles to the mountain.
Just say the globe angle.
Yeah.
It's easier.
Oh, that's not the globe angle.
Of the mountain?
That's twice the drop. 1 degree per 69 miles, or per 60 nautical miles, is twice the globe drop.
What?
Objectively, if you go into AutoCAD, draw up a globe, a circle, draw a straight line, and you will see, draw it all to scale, and you will see that the drop is not 1 degree per 60 nautical miles. It's half that. The drop from horizontal is half that. And I'm talking about a full degree per 60 nautical miles, not a half a degree per 60 nautical miles.
Okay, I just did that on the
231
spreadsheet.
becomes 217.
I just did that on the spreadsheet, and what that does is turn the globe Earth prediction into a flat Earth prediction.
Oh, yeah, you just went from 1 to 2. Oh, yeah, you put that in there. I forgot you did that, Mike.
Yeah, this is something new, and I haven't distributed this one yet. But when it's on 0, this is minus 2 times d squared over 2r. When I put it on 1, that's G.G. Bennett's refraction correction. When I put it on 2, that's just 1 d squared over 2r drop.
Wow, would you look at that?
Oh my
So what
God!
Jesse's
After all that.
arguing, so wait a second. So Jesse, you're arguing. I don't get what you're arguing.
He was just trying to
I'm
kick up mud
confused.
and hope people couldn't see it through.
That's
That's the
wild.
whole point, dude.
Oh, let me
Wait
tell
a
you what
second. Was this in the Prezi?
I'm all right. Was there other people who wanted to
No,
talk?
but
Dude?
it's
I'm sick
now.
of Jesse.
No, let's go. Let
That-
him continue. Let
that's
him continue.
crazy.
What is
Mike just
your
drop his ult?
contention?
Oh, well, what I'm arguing.
He
What I'm
alted. I'm sorry.
arguing.
Go ahead, Jesse. Go ahead.
What I'm arguing here is that even if Earth were a globe, and you adjusted stellarium's time so that the star angle was flat Earth prediction minus 2 d squared over 2r, then moved stellarium from the observer to the occluding peak, it would then match flat Earth even if Earth was a globe. That's my claim, and I think I've demonstrated that because 2 d squared over 2r is very close to 1 degree per 60 nautical miles worth of drop, and that is the offset. That is the target. And can you go back to observer off, please, Dr. Mike?
Yes.
Oh yeah.
Is this what you're talking about? Is this what you want?
Yeah. Can you go back to the observer ATM off tab?
Oh.
The tab.
All right. There you go.
Oh, thank you. Now, if you can click, is it V5? I think it's V5. Click V5 for me. Let me see if that's what I'm thinking of. Yes. So, what you've done is you've literally calculated the predicted flat Earth angle, and then you've subtracted 1 degree per 60 nautical miles, or 2 times d squared over 2r. Basically the same thing.
Right.
So you
Quick, Jesse, real quick, I just have to say something. You messaged me earlier today, and your whole contention was that Mike is not just doing 69 degrees per mile, he's doing 69 degrees per mile twice, that it should be 1 and not 2, and now you're saying 2 is only a single correction.
No, I see.
And I'm still confused what your overall point is.
If you go back and reread what I said, you'll see that I said that the globe drop is 1 times d squared over 2r.
Let's go. Hey, Dr. Mike, real quick. Go to the formula. Change the 2 to a 1. Oh, you were just on it.
Yeah, I'll just back.
Okay,
yeah,
so
he
Jesse,
already did that.
He already showed you this. What are you talking about? You do it to 1, and guess what?
That
That's
becomes
the
drop over
mountain.
distance to the mountain. Yeah.
Right.
Let me know when I can finish my point. I wasn't done yet.
Well, you just said 2
Almost.
is drop over distance. 1 is drop over distance. 2 is drop over distance plus the frame rotation for the 60 degrees, 60 nautical miles per degree.
Exactly.
I don't agree with his frame rotation stuff in this context because factually, if you go into AutoCAD or whatever and draw it to scale, the drop to that mountain, the angle to that mountain, will only be 1 times 2 or d squared over 2r.
Yes, that's what he just showed you. 1 times
Yeah.
d squared over 2r gives you the angle to the mountain. 2 times d squared over 2r gives you the distance to the angle to the star. Like I don't. What are we missing here?
You mean the angle to the star from a
The
different
observer.
Oh, from the observer? Okay, so are you saying that at
Yeah,
the
he
moment
literally
of,
has it. Look, he has it in the observer with atmosphere turned on with 1.
Okay, guys.
Okay, Jesse. Just to recap, 1 d squared over 2r gives the deviation from plane trig to the mountain and drop over distance on a glob.
Right.
2 times d squared over 2r gives you that drop plus the 60 nautical miles per degree of the sky.
Right.
No, plus half of the 60 nautical degrees per mile. See, 60 nautical degrees per mile, or 60 miles per nautical degree, or 1 degree per 60 nautical miles is half, or is twice the value of the globe drop. But so are you saying that
Jesse,
at
it's
the
not.
moment?
It can't be because it correctly gives the angle to every star.
Yeah, so let's actually just do this real quick, Jesse. Do you have Stellarium open, Jesse, still? Why don't we do this?
No,
Nope,
we don't need to
sorry,
do
no.
that. We've already verified it. We know it's about 2
That's
4.
correct. If you go to Stellarium, that is what it shows in Stellarium for 39 Aquarii at that time, at that elevation, and like I don't get it. At that lat
If
long,
it
like that's the
wasn't,
angle.
if we take that second one away, it'll jump up to 217, and it'll be a 14 arc minute difference. These stars aren't off by 14 arc minutes; they're correct. Therefore, the formula is correct because it is correct with
Because it
Stellarium.
matches. Yeah.
Yeah. I mean, you're just arbitrarily saying that it's wrong and then somehow invoking AutoCAD. We don't need to use AutoCAD, bro. We have the trig formulas in Excel. It's doing the same thing. Like this is like a weird thing. Like you're basically saying nuh-uh when the answers are on the screen and they match Stellarium.
Okay, can I ask a clarifying question, please?
No.
I didn't think so. Are you claiming that at the moment of occlusion, the physical angle to the mountain is equal to the physical angle of the star?
Yes.
Okay.
That's how you force the line.
Okay. So then how can the physical
That doesn't make sense to you?
How can the physical angle to the
Please don't interrupt him. Sorry, Jesse. Go ahead.
to the
Sorry.
thank you. How can the physical angle to the mountain be 218 or whatever, while the physical angle to the star at the time of occlusion is 230 or whatever, when that is the moment of occlusion, and you just said that they were the same angle at the moment of occlusion, right?
Are you asking
And that,
why are we doing the celestial theodolite?
Well, did somebody just tell me that at the moment of occlusion, the physical angle to the geometric angle to the star and the mountain are equal?
so
Yes.
Jesse, what you're doing
Yes.
now is you're confusing flat Earth and globe Earth. So this is the different angle that flat Earth would predict, which is the actual measured angle. This is the 1d squared over 2r drop that the theodolite would measure. And this is the 2 degree 4 arc minute uncorrected drop that Stellarium says the observer would see the true location of the star at. And that's what the graph is showing. It's showing you the difference between these various ways of looking at it, where the cyan line in top is the globe Earth prediction with refraction on. The green line on the bottom is the globe Earth prediction with refraction off. And the red line in the center, not deviating from zero, is the flat Earth prediction, which is spot on.
Oh, there's something.
Excellently said, Dr. Mike.
There's
Laid
something.
out.
Jesse, could you respond to that instead of trying to go, something else?
Or asking six more
Please,
hypothetical fucking
please.
questions.
Right, let's get a conclusion from that before we move on, please.
Do you disagree
Jesse,
with
are you
any
able
of
to
that?
repeat back what Dr. Mike just said to you? Steelman, what he said, Jesse?
At least respond to what he said.
What did he say?
All right, I'm done. It's fine. It's
So
fine.
you weren't even
Let's
fucking
quit.
listening?
GG,
No,
boys.
hold on.
Oh my!
Look,
What are we
listen.
doing here?
Hey guys,
Yo,
listen. If I
Yo, one
rambled,
second,
What are
Rob,
we
one
doing
second.
here,
One second.
Jesse?
Hold on, Rob, stop. Jesse, you're gonna have to watch the replay now to get, because that's preposterous, bro. You're mid conversation. He's explained it multiple times. He's changed it on the screen so you could visually see it too. This argument is going nowhere, and feigning not to hear it and then getting everyone upset so that you leave isn't, that's not what we're gonna do here. So we're
No.
gonna get a conclusion out of this, or that's it.
Well, no, in my defense, look, you gotta admit he rambles a bit. He started out, well, here's what Jesse's doing wrong. He's getting confused. He's this and
Jesse,
that, and
Jesse, he
I'm
rambles
really
a bit. It's not a sufficient take here, right? I gave you the floor for like over an hour of this for you and Mike to have like a one-on-one to go through every strenuous aspect of what you wanted to go through. So don't be like, oh, he's rambling on, right? You've had a majority of the floor to speak to get your point across.
I
If you
Terrible.
can't
for a
pay
couple
That's
of
attention
minutes.
and you're
terrible.
I've got to
being
go
answered and
shortly.
responded to, then that's disingenuous. That show, like, if you want to be here and then be a part of this, then you can't behave like this in the middle of the discussion and then feign ignorance.
Right.
And
All right,
only
can I have a
to
couple of minutes? Because
come
I
up,
got to go shortly.
Do you have a
Ruhiv,
only
question,
you're
to come
actually
up,
Ruhiv?
not even part of the
You can leave
discussion
anytime,
anymore.
Ruhiv.
Same.
yeah,
Yeah,
only
you're
to
actually fully done, Ruhiv.
Yeah, I
only
know
to
you're
come up
scared.
short.
I know you're scared.
Oh,
All right, I want to
dude.
talk about my video yesterday.
No one's
So I
scared of
Oh
you,
my gosh.
Ruhiv.
Only to come up short in the end when asked the question about why is it that your model has to use all these custom coefficient corrections that are empirically derived for quote unquote celestial refraction to lift the star up to match the mountain because you claim all the angles are physical. And then all Mike had to do was say, oh, here's a quick 2 times d squared over 2r. Look at that, dude. Wow.
Yeah, that's
FE
pretty
angles
wild.
everywhere.
because
Just a
that
giant coincidence, right? You have to appeal to coincidence
And
if you
no
want to be logically
response.
consistent.
One of the reasons is you're looking very low on the horizon. Generally, you don't pick stars to do fixes to if they're that low on the sky.
Or the reason is I don't look at numbers. I just talk in broad generalizations.
I know you just make shit up and talk. I got it. You don't look at how stars.
Yeah,
Wow,
elaborate
Mike, this is a
then,
bad look.
Mr. Starman.
No.
No,
You
we
don't
can
look
ignore.
that.
Can we
We can ignore him.
look,
We're
No,
Dr.
never
good.
Mike?
mind. That's a derail. I don't want to derail. I want to get a response to what Dr. Mike's saying.
Hold on
Right,
one
well,
second. So while Dr. Mike is here, who's sharing his time with us because he does have to run a dog rescue, you know what I mean? Like, does anyone have any like clarifying questions or want to go over anything?
Yeah, actually, what we're gonna do here is I wanted to add new data to the spreadsheet or whatever. So if you wanted to go over that process real quick, Mike, and then we could wrap up this session of celestial theodoliting. There was a bunch of questions, but I'm pretty sure we can answer all of those without needing you to be here if you have to go soon, Mike.
You mean we can
Okay,
add a star
yep.
live?
What's
Yep,
that?
we're going to add a start live.
Yeah.
Oh,
And what I
pretty sure
recommend
Jesse asked
is
for this earlier.
I recommend starting on the Observer ATM Off tab and just copy something that's already there, and then I'll paste it. And if you could, there was one star, right? Are
Alan,
you
you got the
there,
data,
Alan?
right? You can just tell
Yeah, I
you can
think
just tell
so.
Mike and he can type it in.
Yeah, that's what I was hoping for.
Yeah, give me 1 second. I'll look it up.
What was the name of that peak?
I think he's looking it up.
Houndstooth.
Say that again.
Houndstooth.
Houndstooth. Okay.
The
You can
dog
laugh at my typing.
houndstooth.
What a perfect
I'm just kidding.
choice.
I'm just kidding.
Oops.
Houndstooth.
Oh, you put the dooth. I might
We're
actually
gonna-
laugh at your typing.
Yeah, you can laugh at my typing.
To dooth.
And then when you're ready, just tell me what you're going to give me, and I'll go there and we can add the data.
Yep, just going through our email history here.
I just want to say this is fantastic work, boys. Well done.
Nice. Thanks, Register. Dude, grab the spreadsheet while it's there. People can do their own observations. Produce more
Here's
data.
my question for Michael. He's doing all this stuff about the predictions of the occlusion and all that. But where's the flat Earth prediction for Polaris from all locations on the Earth for the azimuth and elevation?
Oh, that would require
Where's
unlimited vision, and we don't have that, so that's not.
no. Where's the prediction for that? So that if I know, where's the flat Earth prediction for any celestial object? Where's the flat Earth prediction for the location of the sunrise and the sunset?
Spreadsheet, and then it's followed by celestial corrections in the form of refraction to facilitate it. So you're looking at
So okay, can I see the calculation? So let's say that on a line of
We've been doing it for
longitude.
2 hours. Just go back and watch the video.
On a line of longitude, where's the flat Earth prediction
Oh my
on
God.
a flat Earth using a tangent function that
Can you
shows?
stay on topic, sir?
This is different, yeah, dude. Polaris doesn't occult any mountains. It's still.
He's gonna have to go watch the video. He's not gonna come in here and ask us to start. It's crazy how many people come in here and try to do the same exact thing. It's like they're desperately like, no, don't show me truth, anything but truth.
I think it's
thoroughly discouraged from their point of view, and they cannot concede that it's even shown correct, let alone that it destroys their ideas.
If Mike's stuff wasn't correct, all the angles to the stars would not be correct on his star true position sheet.
Mike, what do you need right now?
Of this whole thing.
Oh,
name of the star.
Mike.
We need.
I've got the name of the star now.
Official altitude and distance
Yeah, I'll need the official altitude and distance
of the mountain.
So do you have the altitude?
Mike, what website do you use to get your altitudes?
Do you just get it off Wikipedia, Mike? Or
I usually go to the official site. I see Alan gave it to me.
What's that?
5.4 miles.
Is the distance?
The distance?
Oh. Yeah, you do 8,803 meters.
Does Pikes Peak ever occult one of the 50 or so stars?
No, Mike, it's 8,803 meters is the distance.
Oh, that's the distance?
Yeah.
Now, can I have my couple of minutes and then go?
Have you guys ever thought of using one of the 53 celestial navigation stars that we know the elevation to?
Yeah, mountain height, Alan.
Mountain height was 4,626 feet.
Feet. Wait. Yeah.
You don't want meters?
Can I make my point and then go, pretty please? Pretty please, mods, can I make my point and then go?
No, Ruhif, you're actually done, dog. You can't come
You're
here
so
and be like,
scared,
I
Alan.
didn't listen
You
to
are
anything.
absolutely terrified.
No.
Here comes
No, dude, you
We're not
Did
doing
I
disqualified
do that
the
right?
yourself.
trolling. They're
Divided by
inputting. They're
divided by
inputting data
3.27,
right
Mike.
now. We're
It's divided
finishing up
by
the
Sorry,
time.
presentation, guys.
he left. He said he wasn't paying attention, was playing Balatro the whole time, and then is complaining about not being able to participate.
Wait, is this in feet, Mike?
About the sheets in meters.
Yeah, isn't it divided by 3.27 to get meters? Times. You're on the right box. Just the formula you just put in.
1410, it looks like.
What's that?
I just did a feet to meters conversion, and it looks like
Okay.
that's the right number.
Okay, word.
And okay, and I'm going to need to convert the latitude and longitude to decimal.
Sure, lat long, Alan. Or sorry, at the observation. I mean,
Houndstooth, Utah.
Observe coordinates. 1 sec. All right. I'm gonna copy paste them to you, Mike.
cool.
Oh,
And the star name and all that.
Yep. 1 second.
I got this for star name.
Oh, okay. Was that? I thought that was copied. My bad.
Oh, it was copied, but then I looked at Alan's email, and I was trying to copy as much as I could from it. I got hung up on the observer location and the peak location. So this one is the observer location, and I
Yes.
need to convert that to decimal.
Okay.
Alan, that's your parking lot location. Is that correct?
I've got it Wolfram up if you want me to convert it, Mike, or Alan, if you
Yeah,
want to send the
if you
lat long
could.
to me.
Yes, please.
What about Polaris, though?
I don't know, dude. We need a mountain. Need a mountain tall enough for it.
What up, what's it?
That.
You see the presentation?
No, I just jumped in.
To hear the gish gallop. Well, what about stuff I've overheard in the sunset, stupid flirt?
I'm not
Just
sure
DM it to me,
what all
Alan.
you guys said, but I know that the ballers don't want to talk about it. Apparently,
Oh, not only do they not want to talk about it, they want to spend like an hour asking to look at one star and adjust its position by 26 meters and waste, more time than the presentation took doing that, only to come away with no conclusion in the end.
I like how so you can tell the strength of the position. They chose to spend 2 hours on 3 of these measurements, and there's 46 others. So even if we were to just give them 3, we still have 43. But we spent time enough on those 3 to know that actually they were wrong and they were misapplying the whole formula, and we were right the whole time. But if you look at in its entirety, 46 measurements flat Earth every single time, and the graph that we keep putting up is the nice pictorial representation of the nonsense, right? There's no way to finagle this. There's no way to say this predicts globe and concave and other nonsense. No, flat is within like 5 meters of the peak elevation prediction every time. The globe is wrong with refraction, with d squared over 2r, and without it. Each time it's wrong. And that graph I think he put together really shows that. So you can't eke out of that. And that's why we spent 2 hours talking about not that.
Nice summary.
Yep, that's pretty much it. They're very scared because it's an actual flat Earth prediction versus globe prediction with refraction incorporated. He laid out all 3 in a nice visual graph for everyone to see, and it's pretty substantial. It's insane how much deviations off of flat. It's like 1 meter, 2 meters max. And then
I just want to say,
yeah, sorry.
Go ahead.
No, go ahead, Rob.
No, I was just gonna say, like, I have a very limited knowledge of the celestial satellite, right? I've only just listened to you guys all present it. But even in my limited understanding, it's like all I hear from the other side is how it's just wrong, but didn't actually tell you how it was wrong. And then when you brought up that the occlusion time and the star disappearing time were the same, and all of a sudden they just went haywire, and Jesse said that your measurements were off, and that's when Dr. Mike told him he was confusing the flat Earth measurement with the globe prediction, and then we didn't get a response to that.
I like.
I don't even know if Jesse's still here.
Dude, I like the
I'm here.
part.
I
Thank
disagree.
you guys for all the work you're doing on this.
I like the part where Mike built in Jesse's response live time to an actual GUI button, which I thought was a nice touch. And he could turn Jesse's response on and off at the flick of a button. And then we spent 3 hours talking about that. That was my favorite
That
part.
was Dr. Mike's ultimate was right there. That was so funny.
I wonder if it's back off cooldown yet.
Can I say something?
I prefer not, Jesse.
All right, Jesse. Well, I mean, he's the only one
Are
that
you
tried.
gonna respond, or are you just gonna bring up something new?
At least he tried.
Well, what if, though? Let me ask.
Go ahead, Jesse.
Oh, thank you. I disagree with the allegation that I'm confusing flat and globe prediction.
That's it? I thought you said you had a question. That was a statement.
Now you just want to tell me I was strawmanning him somehow.
Oh, I do have a request, Dr. Mike. Could we work at not on the session, but throughout the week, work on a step-by-step procedure that anybody can follow, a written step-by-step procedure that anybody can follow as a go along with the video here, so that, because we all need to be able to do this, right? We can't just all rely on one person to do the magic. All of us need to be able to do it, right?
So
Yeah,
my
check it out.
understanding.
He's making the tutorial right now, bro.
He's literally doing it before your very eyes with the star that Alan just recorded the other day.
That's
Alan recorded
confusing.
the conclusion.
Well, that's true, and that's wonderful. But after this, if throughout the week we could make a step-by-step that is a companion to the video.
I'm gonna clip this out, so stop talking and let him do it or whatever.
Is this where only Jesse's observation actually matches the globe?
Only Jesse's curve calculator or whatever.
I don't even
I'm
think
joking.
Jesse's observation matched the globe, but
Yeah, actually, what's it? You weren't here, but to give you the TLDR, if we don't use refraction or celestial correction, which they call refraction at all, we don't use any of that, and we just say, you know what? We're just going to use 2D squared over 2R. Magically, every timing that Dr. Mike measured perfectly matches an FE baseline.
And Jesse's measurements.
And I will debate any one of you in a fair, moderated debate on that point, because I disagree that
It's
it's
been ongoing
pass.
right now, and when you were asking
Literally
a
been
question, you
that
said
all
you couldn't
night.
hear anything, and that the guy was rambling. So,
Yeah.
like,
Literally didn't
Yeah,
listen
it's
to
kinda fucked
anything.
up, Jesse.
You were faced with a direct question, and then asked, and then when you couldn't answer it, you're like, "Hold on, what did Dr. Mike even say just now? Can you steelman him?" And you said, "What did he say?"
Yeah, you were just waiting to
I wa-
speak. You weren't listening.
then-
That's the worst kind of conversation.
Well, and then you accuse him
Yeah,
in
it's
live
called
chat
bad faith.
you accuse him of live chat for being rambling, like calling him out when he's literally right in front of you. Like, what are you
real
doing?
Quick, I have a question for Jesse. Hey, Jesse, can you hear me? Can you guys hear me?
I
Yes,
can hear
Lily.
you.
Okay. Hey, Jesse, I heard Dr. Mike say at least half a dozen times that you misrepresented him, like straight up, and that you said that he said things that he did not say. Like, I heard him say that at least half a dozen times. And I want to know, why do you do that? Like, as a part of the audience, that is, to me, it's like, for someone to say half a dozen times that you are misrepresenting him very, very deliberately, it's like it makes everything you say completely without value. Like, why
Do I get to
aren't,
respond, or is this just an attack?
it's not an attack, it's an
Okay, let me
observation.
respond then. Mods?
And
Well,
it's a
she's only been talking
question.
for 1 minute, bro.
Well, she said enough. I need to respond to it before she moves on to the next set of attacks. Okay.
No, that's well,
Okay,
no.
so
Thanks
first
for
of
your
all,
opinion.
this is not an attack. You're attacking me by
I deny
making
the
me
allegations.
look.
Okay, cool. No, duly noted. Be quiet.
I'm
Yeah, I
just
deny the.
asking you, why are you misrepresenting him? Why?
I'm not. I'm not. I'm definitely
Okay.
not.
All right. Okay, that's it. I don't want to hear anymore.
Oh,
I
sorry,
will say there's
Lily.
a long list of things that I don't miss from stepping away. Chief amongst them is sophistry by way of Jesse. So
I'm still waiting for those 30 PDFs you're
Sophistry.
going to
That's
get
a
me
great word, Winston.
when you get back
Hey,
from the
boys.
gym.
Hey, we're not going to get into it. We're waiting for stuff from one side or whatever. Stay on task, boys.
Did you guys finish adding your star?
So
Did we make a new
the
island?
only thing left. The only
We
thing
were
left is
on data being inputted.
the only
Jesse,
thing
they're
left is
trying
the
to input
JFW.
data.
Rob.
Hey guys, I just want to add, like, sorry, this is Goose. Jesse's
What up, Goose?
Jesse's put in some effort on the celestial theodolite, so I think we should respect him for that. At least, like Jesse.
Goose, is that your
why
only
is-
contribution? Because we can probably. I'm just kidding.
No, sorry. Yeah, just like Jesse, why is your radiator strapped to your car right now? Like,
Oh yeah.
like he's been out in the field trying to get this stuff. So I just think he's
At least he's
got a
trying. I
voice.
agree,
We may
Goose.
not
He's the only one
like
trying to address it.
his voice. We may not appreciate his voice, but I think he is out there trying to get the measurements. And
Do you think it's his voice that we mainly disagree with?
no, I get it. I get it. But
Let me ask a question which is of some importance. It may have already been answered or discussed, but Jesse is here, Dr. Mike is here, Alan is here. You've all made measurements, and as you all know, precise timing of the measure of the observation is required. So how are you measuring the time to the accuracy that is required?
Our devices are automatically synced to GPS time.
Right. So how do you make sure when you take the measurement, you're getting accuracy? You don't have, got
It's recorded.
in the
It's recorded.
There's
and it
video.
has a timestamp.
Yes. What's recording it?
A C-star. A C-star telescope that records.
Can I address that?
Okay. Yes, please.
The C-star creates a video file of the frames that it takes, like one frame per second is what they had it set to, and the file name of the video file is the date and the time to the nearest second in the local time zone of the phone that's operating it. And so then you just apply a timestamp overlay in a video editor that starts at that time and then counts up 1 second every frame.
All right.
And is
Dr. Mike,
it?
do you need the J value? Oh, sorry.
Oh, let me just ask a quick. Is it GPS time or UTC time or local time?
Local time.
Okay.
Whatever the
Okay.
phone is set to.
Okay.
Eric,
And
you can go
Oh.
watch Jesse's videos and you can see the timing on his videos and see for yourself what you're looking for.
Okay. Did Dr. Oh, okay. So Jesse has it there, but did Dr. Mike use the same method to get the timing?
Basically, he counted frames, and so he viewed it in a video editor or displayer that showed him the frame number in the sequence in the video, and so then he in the spreadsheet has a column for a first frame. It's column B right there if you're watching a screen share, and that's the time of the file name and the first frame. And then in column C, he has frame number, which is the number of frames into that clip. And then he uses some math in the time column to calculate a timestamp for that frame, if that makes sense.
Okay, yes,
the
it does.
occlusion was observed on.
Initial alignment is very accurate, I hope. So, with the
yeah, and to answer your question too, I've used like a stopwatch sync to UTC time, like local UTC time.
Okay.
There's a number of ways to get your timing down.
Yeah, it only
You
needs to be
could
accurate within 1
effectively do
second.
it with binoculars and a cell phone. You could effectively.
I've done it. I've done it with my bare eyes and a stopwatch. Like, it's doable.
So this recent measurement, what is it, hound's tooth? This was done last night?
No, on the 27th.
Okay, so gotcha.
Dr. Mike's on it. Look at that computer science brain go.
Do
Heard that
we need to
immediately.
go into Stellarium in order to get the J value?
Can I have the button version so I can turn off Jesse's meek objections over and over again, and I can see how they're irrelevant to the huge data set, the mean average, and the results? I thought that was a good touch. I know that you didn't distribute that version yet, though.
So one thing I still need that I don't have yet is the latitude and longitude of the peak itself.
One that Alan, what peak?
Tooth.
The
Is
target
it the,
coordinates where it says target or tar. Sorry, I abbreviated. The tar coordinates are the peak.
Okay. Got it. I'm going to convert that to decimal.
Gotcha. So you have to make a decimal conversion. So to put in the latitude and longitude, you need decibel. Long and lat.
Decibel
Okay.
is too loud.
Sorry, I'm a little baked.
It's okay.
So.
Thanks, Eric. But yes, anyone can do this, Eric, very accurately. And you're
yes,
basically matching it up. You can match it up on your phone. To the Sea Star, to Stellarium, to Gaia. If you want to use other ones, doesn't matter. Like you can corroborate it multiple ways in terms of the time.
Yeah, the C Star is nice because it, like, when you save your video, it just timestamps it, like right when you started it, so you can just offset from that timestamp in your video. And like Jesse was saying, you could just overlay a frame count or a time count, and you can get the exact second where that star is included on the video.
Do we?
And you don't really have to be super accurate either.
The J value, Dr. Mike,
for what we're doing for measuring deviation between flat Earth and globe Earth, you don't have to be that accurate.
The
It's a
observer
huge difference.
ATM. The observer ATM on has a J value in there where the other two don't, Dr. Mike.
Oh, I didn't explain this very well, but only the J value in the observer ATM off counts, and the others just automatically. Well, I must have mangled that when I copied it, but they're supposed to automatically reflect that.
Okay.
Let me see if I got the. So it looks like that did okay.
Field.
Yeah, this column I, which is the J value on observer ATM off, is the only one that actually adjusts the timing, and the others just echo that. And so I think I've gotten the latitude and longitude right on all of the tabs. I just kind of copied that. The ATM off is showing that it's 11 meters below observable with atmospheric correction off on globe Earth, and it's 600 meters low on globe Earth for refraction on. So that's something's wrong with that. That it's 109 meters low on peak altitude. So I think something here isn't quite right yet.
There might be a field that was copied that you didn't take out, maybe.
Yeah, actually, it looks like right here is one mistake. And let's see. Oops. Yeah, actually, I'm gonna copy this whole line. Oh, I was overzealous because I need the actual. Oh, I don't know how I did this. Oh yeah. All right. I think I'm catching on.
This spreadsheet had to take quite a lot of work. All the formulas and whatnot. It was well done, man.
It did take a little while. All right, so I've got the
There's some
correct.
formulas that you got in here that I didn't even know existed. Really good stuff.
Well, several of these I derived by myself by observing what stellarium was actually doing to us. And so some of these are brand new, newly discovered that this is how stellarium is turning flat Earth into globe Earth. So it looks like I still have some pretty. Okay, this is showing no deviation.
You got the same values in there as you do the line above, I think, unless it's not pulling off that page.
Yeah, let me see if. Okay, yep, thank you.
It's not copying a
Right.
formula. It's just putting a raw number in.
Oh, actually, that was
Also,
my bad.
Some of
I
the
should have.
formulas, Dr. Mike,
Got
some
it.
of them when you copy and pasted it, it might have moved like
There you go.
V5 down a few rows too. So you might just want to double check some of the formula boxes.
Yeah, I think you need to do the whole line formula copy.
So the reason I didn't do that is because I had already spent a lot of time calculating the correct right ascension and declination, because that also has to be in degrees.
Real quick, those three are also copied straight up, not the formula, just the value. Your column L is correct, but your M, N, and O are not. M, N, and O are just straight value copies, not formula copies.
Yep.
Okay, those two I want to be actual numbers. If these two should be formulas, so they're still not formulas. Okay. Formula?
That one got
check
it.
through.
That one didn't. You're gonna have to copy that one
How
individually, I think.
weird.
I think it only does
This
one
is
cell for some reason when you do the formula paste.
yeah, that's kind of weird because I always thought that
Oh,
worked
the formula
before.
still didn't get copied.
I think it's moving the check the cells in the formula. It might have kept the exact same cells when it couldn't, and vice versa.
Oh, there's a bunch of non-formula cells.
Oh, okay. Actually,
oh, you just typed those in from
undo a couple of
Stellarium.
these. Oh, this one needs to be unchanged. Okay. That's the actual right ascension for the star, the actual declination for the star. This
still
should be calculated.
Yeah, your right ascension and declination are just values, but you do need to put them in because those aren't the correct ones. Those are just
that's
copies.
not it's copying the same row above for the declination.
Yeah.
And
yeah, you got to change exactly.
right ascension. The right ascension,
Okay,
declination are still the same as the top one. Oh, there you go.
I'm gonna copy these
grab
two
those. Yeah.
and hope they're right.
There you go.
Okay, so that's an equation. 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 That's an equation.
Did it slide over
So some
one?
I
No,
think
it
those
just has one.
columns might be to the right one cell and need to move, or to the
Yeah.
left one cell
yeah,
and need to move
I
to the
think
right
you're
one
right
cell.
because that is a declination. Oh, that's the
Yeah.
declination. But okay, it looks like I'm gonna have to go back to Stellarium and recalculate these values.
Mm.
I got two trigger happy copying. Oops,
You control Z a bunch?
I thought so, but that's not gonna work so well.
You just got to get the right
So I'm
ascension and
gonna,
declination right.
yep, I'm gonna put that star back into Stellarium and just calculate it from here.
Date and time, yeah.
So the right ascension is 21 hours. I'm 60 plus 1 minute. I'm 60 plus 20 seconds. Divide that by 240. And that is the angle. And that is right ascension angle. So there's the right ascension angle. And now I'm going to calculate the declination. So 4.7 seconds divided by 60 plus 57 arc minutes divided by 60 plus 12, and that's negative 12. So I will just copy that negative sign. Okay, now we have the correct right ascension and declination. So I will copy that to these other tabs. All right. So it's still saying the deviation is quite a ways off, but I copied this altitude and this distance out of the email. Did I make a mistake on either of those? This
Official
says the
altitude and
target.
distance column is different. Do you see official altitude on the left and official altitude on the right? So your column F and your column Q are different, Mike. That's 3067 and the other one's 1410.
So
Is your observer height affecting things?
I'm not sure that second one matters, but I'm gonna correct that just in case.
What's your observer height for houndstooth?
For that, oh, I've got the wrong observer height too. So that's the leftover observer height from that I copied.
Yeah, why
Whoa.
isn't the second observer height on the right? Why is it not in the above rows?
Actually, I think it looks like something got terribly off here. So I'm gonna
Yeah,
just
I see
copy
that
this
now.
whole batch.
Yeah, copy and pasting a bunch of different type of formulas where some of the cells in the formula stay constant and some of them change with the row. Sometimes that gets all funky when you try to copy and paste.
Yep. So we've still got a huge deviation. So something is still wrong here.
Can you just go to the Observer ATM off page and go up and copy like line 54, 55, and 56?
Yeah, so this green sheet, it doesn't have the second altitude and distance on the right, whereas the other, like the blue spreadsheet that you had, it had two of them at the bottom, like on the Hound's Peak or the Hound's Tooth.
Yeah, I got confused by that at first, but that was actually a copy and paste error. So this is correct. But
Even
this one
so,
is
the blue one that you were
wrong.
just The blue one that you were just on though, Dr. Mike, you notice how it said altitude and distance on the right, but it's not like that on any of the rows above it.
Yeah,
If you go
that's
back
what
to the blue,
that's what he's saying. See right there? See how it says peak, houndstooth, observer? It's not if you look at the above rows.
yeah, like look at the
If
highlighted
you
blue at the bottom. You
Blinn
see,
Mountain, for example.
Yeah, I think you need to start from column L and go all the way right from column L, Mike.
So I can't do that because it's got right ascension and declination right in the center, and we can't change those.
Mm,
Oh,
you could.
You see that?
But
there you go.
in the highlighted ray.
Yeah, this stuff that is
Yes,
just
that's yep. That's just extra.
okay.
Yeah, I don't know if it's tied to any formulas. I just figured I'd point it out because it's not in any of the above rows, you know.
Okay, this still does not have that formula there. All right, and let's check this one. That one also does not have that formula. And then let's check this one. This one has that same problem. Okay, but this has a pretty significant deviation for the altitude, so something is still wrong here. So we've got the formula, we've got the right ascension, the declination. I've got the time. And it was the 27th.
I think I saw a problem in the one formula a couple boxes ago. You had F59 showing in one of the formulas. I think it didn't copy correct. I think it needs to be F68.
Let me check some things here. Okay, so that's right.
Well, boys, I'm gonna get off here. Let me know what happens with your measurement on here, Alan. I can't stay up any later.
Yeah,
Yeah, I gotta head
we're
out
about
too,
to
but
head out and do some
phenomenal guy.
self-theo measurements here. So we'll be wrapping up shortly. And then
I'm sure Mike can fix his
some-
spreadsheet, but it'd be
yeah,
nice
we
to
can-
see it alive.
Right. We'll record something tomorrow and so that it's not all long and drawn out with explanations and stuff. And I'll do a written explanation and put it up on the what do you call it? The Obsidian database.
Mhm. So, Mike, to be clear, before I go, and thank you for giving the pres, by the way. So there's two things that you did. Number one is you corrected right angle and declination into azimuth and elevation. And number two, you took the occlusion time that you recorded and compared it to the overlap in the angles of the star and the mountain and stellarium to get the J.
So to get to J, I find out what the reported bearing is to the peak, and then I try to figure out how far off that star occluded from the peak, and come up with the J value that puts the azimuth where it belongs. So, like in this case, it's saying it belongs at 9738.1, and it is 9738.1. So that calculation is apparently correct. So that's already on the right azimuth. And I'm not seeing yet.
Right there. Go.
What?
Hold on. Stay there a sec.
Uh-huh.
Look at the formula at the top. It's not showing 68. Is that correct or no?
It's F59 or whatever, T59. It's 59 instead of 60, whatever it's supposed to be. So it got the wrong column number.
Okay. T.
And I think
And
that's
let me
the issues that I've been seeing. I think it was just a copy mistake. So once we fix that, it should be
It
good.
directly copied the formula instead of the row associated formula.
Okay, so that needs to be. Oh, okay. That's this. And what is that? Oh, that's
Those are just
apparently.
numbers. You didn't
I
copy
think
formulas there.
these are the actual. That's supposed to be the actual bearing of the peak. So if the bearing of
Okay.
the peak is wrong, but this should be T66, so that's a good catch. And
The
and of
actual
course,
bearing of the peak isn't correct though, because you just copied that from Blind Mountain.
exactly. And I don't see the bearing on this spreadsheet. Oh, here it is, 117.2303. So, actually, these might be stellarium numbers. Um, uh, is Alan gone already?
No, I think he's here.
I'm
Do
here.
you know
What's
what
up?
the bearing is? You know what the bearing is to house peak from the.
No, I don't recall. I think Jesse calculated it for me though. Maybe 1 second.
Don't you just go to your location and then point to the mountain and get the angle to the star?
I calculated it for a different star from the same sighting, but a different star.
Well, what one is Mike using? Because I just copy pasted what you sent.
Oh,
You should be
well,
using HD 199.828.
let me look. I think I had a bunch of zeros. The one that I actually found the exact point of occlusion and calculated everything. I listed a bunch of them, just saying, yeah, here I've identified these in the video. But the one that I actually got the coordinates for and the angles and everything exactly had like a bunch of zeros. Let me look. Okay, the one I gave you all the. Oh, it was 199.828. Okay, I got that right here. I do apologize. The bearing. Where did that go? I think I thought I gave that to you.
Did you say 199.828?
199.828.
199 or 119?
Yeah, I think
199.828.
199.
Dr. Mike, I think you might have put that in wrong.
It's 199, not 119.
I have the, let's see, the azimuth angle according to stellarium and the altitude angle according to stellarium. And the
Okay.
observer coordinates, did I not? I know I calculated that. Well, let me go do it. I'm not.
Yeah, you guys have fun.
I will get the azimuth angle to that star occlusion. Hold on.
Oh, wait, that's where I was. I was recapping. So it's not that you compare the occlusion time to the time. It's the time as compared to where it's supposed to be at the correct azimuth for occlusion.
Yeah, so right now this is saying the azimuth was 97 with the data we have, and if it's supposed to be at 199, it's about 100 degrees off, 102 degrees off.
Yeah.
So, and oh, is this in New York or where is this?
Utah.
Utah? So that would be 6 or 7. Let's try
UTC
7.
time zone.
I think it's mountain
Yeah,
time.
if it's mountain time, that's 6. So it's still off by about 80 degrees, 82 degrees.
Yeah, I think the numbers in there are not the right ones. I mean, all you got to do is go to the
What about
observer location and point at the star, right? And then you'll get the numbers from Stellarium.
what
Well,
about cell
this,
S68?
this bearing, what we're trying to get right here is what NOAA or Movable Types says is the final bearing. And then we're also going to
Oh,
need the initial bearing.
What about
So we need
S66 and S67?
I
Aren't
mean, bearing
they
is just
wrong
from you to
still?
the mountain, right?
these are calculated based on the time of the occlusion in the star and its right ascension and declination. So that's all calculated, but the value in column T in the heading needs to be the actual final bearing for peak ATM off and the initial bearing for observer ATM on or off. So
So then either
that
we've
needs
got that wrong or column S could somehow be wrong, or is that what you're saying is
S is
calculated?
calculated. Yeah, S is calculated, so that can't be
Okay,
wrong.
so T must be wrong then, right?
Right? T must be wrong. Well, maybe no. There's something more wrong than that because look, it's way off on the well, yeah, it's way off on the altitude, and this part of column T is for comparison only. This part of column T is actually calculated. So the calculation is off, but so is the peak altitude is way off. So if this is if 3067 is the correct altitude and 8,000 804 meters is the correct distance. Well, something here is wrong. We've got bad data. It's hard to identify what it is, but it looks like
Yeah, could that
this is the
distance be
data I
wrong?
had.
That distance does seem rather low, at least compared to the other observations.
No, they were only like 9
Yeah,
kilometers away.
Okay, all right.
yeah. This says 5.47 miles, and it says it was 8803.8 meters. And let's check to see if that's what I copied in. 8803.8, and it said it was 3067 meters altitude. Oh, it does say it's according to global Earth. Let me see what. Um,
I do have a bearing if you're ready. And this is for the observer location that Alan gave me and for the latitude and longitude where I determined that the star occluded on the mountain peak. And this
okay, the
bearing,
observer initial bearing.
okay, and this is from the movable types because the other one is being really slow. So this isn't perfectly
Okay,
accurate because it assumes a perfect sphere and it doesn't take into account the geoid. But the initial bearing is 117 degrees, 28 minutes, 32 seconds.
okay, 117 degrees, 28 minutes. How many seconds?
And 32 seconds, 32.
Okay, and then we'll need to convert that. So let me do that real quick, unless you happen to have it. So 32 divided by 60
I can convert that real quick.
plus 28 plus 117.
Still seems like something's going to be off. Like that's such a bigger discrepancy than the other observations.
Yeah, something else is still wrong. We'll have to figure out what it is.
So when you said that column S is like a calculated cell. Is that with a formula from the cell that we could look at to see if it got some of the wrong, like, individual
So
cells in it?
this is the formula from slide 11, which is giving exactly stellarium values for everything else here. So something else is wrong. It's not that formula. It's a calculated value, but it's being calculated essentially exactly the same way stellarium calculates it. So it's still a
Oh,
mystery.
listen, it's averaging 2 rows with nothing in it. They might be counting them as zeros, maybe, because it says average S or whatever 68 to 72.
What cell are you looking at?
I think it was S68.
So
No, try
S68 is a straight
one over.
calculation.
Try.
And that's just a conversion
Nah, that
from
it
degrees
was the
to
one that said average. It was just a short
the
formula.
the averages are they're they're just for display purposes. They're not used in any calculations.
Nah, it wasn't over there though. It was one of the. It was. I think it was in either S or T column.
Okay, I'll need to know the exact cell.
Can you just click like S67 and T67 real quick?
Okay, there's S67, there's T67.
What cell were you on right before this?
That was S67.
No, right before that one. Sorry.
I'm actually not sure.
Ah, it popped up again with the average, and my worry is so it had average, and it was like cells S68 to S672, and I was just wondering if, because there's nothing in cells S70, 71, and 72, if that was counting them as zeros and throwing off the average. You know what I mean?
So you may be looking at something like this, and when it encounters blank cells, it just ignores them.
Okay. Yep. That's exactly what I was seeing. It wasn't that cell, but exact same formula and the exact thing I was bringing up. Okay, good. So it just ignores ones that
And
aren't there. All right.
and then this one that says div 0, that can't ignore them because I asked for the standard deviation too, and that's why it's showing a div by 0. But that's just so that's so I can tell how close the numbers were. But I can see just by looking at it, it's way off on the calculation for some reason. And it's off based on the elevation. So the elevation is calculated from the time and the longitude, latitude and longitude. But those look like the latitude and longitude that were in the email. I'm going to just, let me see, that seems to have an extra digit for some reason.
So the cell that you said was off, what was it, the deviation or something? Can you click on that cell one more time? Sorry.
Yeah, that would have been calculating the standard deviation. And you can't calculate a standard deviation from one cell, so it's a division by 0.
Is that the one you said you can tell is off though by looking at it, or no?
No. This is what I can tell is off by looking at it.
Okay, hold on.
And also I can tell this altitude
Right.
is off
Can you
because
stay on that for
we're
one?
talking about a. Yep.
So you see in the formula at the top, it says B60. Is that what it says? Should it be
V68.
B68?
Okay. It should be V66. Oh, wait a minute. Let
Well,
me
that one I think's right, but what about the
hold
yellow
on.
one?
E65. Oh, let me just copy this down here. And then that said B60, and it should be B67. Okay, I think B67 is wrong. What's the observer altitude?
It had B60 in it though, right? Like I think it
The
was just a copy or
the
Well,
observer
I just fixed that.
the observer. Oh,
oh, nice. Okay, good. Yes, you did.
oh, observer height 1411 meters.
There's another 60 at the top. You see it, Mike?
Yep, I see
Yeah,
it.
right
So
there.
that
Yep.
should be 67.
And this is, I think, the issues that we're having. I think once we sort these, we're going to be good.
Yep. And the observer height, Jesse, what'd you say it was?
1411 meters. I have it in feet too.
Okay, I do everything in meters. And I explain in my books why I do everything in meters because you're shooting yourself in the foot if you're using feet and inches and yards, and meters are consistent.
And it's easier to swap decimal places if you need to convert it to something else.
So I'll need to um, fix these numbers everywhere else. And so that looks good. And then these probably
And the
have the
formulas you got to
same.
fix, though, right?
Yep, we'll have to fix
On
the
the other sheet.
same formulas. So this one, that says X59 and it should be X66.
The yellow was wrong too, though, right?
And this says, that one looks right.
67, right? Not 66.
And this one says 59 and it should
Mike, I
say
think
66.
the last one you did right before this, you might have missed by one row.
Ah, oops.
So I think it should be B67. I think you had B68, maybe. Yeah.
Okay, this is altitude. So 66.
7.
Oh no, yep, should be 67. And this says F60 and it should be F67.
Yep.
And uh, this says T59 and it should be T66.
All right, I have calculated the forward or the initial and final bearing and reposted those to Alan in DM.
Mike, I think the last one said 68.
You those to Mike DM because I'm.
Yes.
Yeah, it's got to be B67, right, Mike?
Let me see.
Oh, wait. Never
This
mind.
is B60, so this should be B67. Okay. So that's right.
What about the F? Is the F right? F6. Yeah, okay, good.
All right, so we've got the right observer altitude, the right peak altitude. It looks like it's calculating the difference correctly. Um, this is a pretty high elevation, but it's also pretty close, so that would explain the high elevation. It seems to be saying it's 200 feet below the, sorry, 200 meters below the prediction. So actually, that's
It was that
better.
97 number correct, or was that before it was converted? Because I think on two of the colored spreadsheets, I think that 117 number was still in both spots in the S&T.
So I haven't. Let me see. This is the final, or sorry, this is the initial bearing Jesse gave me, and we still need the initial bearing. Sorry, the final bearing for the peak. But right now it just contains the initial bearing, and uh, until we get a better number, that's okay because it's not used in calculations. This number just tells us, it gives us a quick indication if this is wrong, and this is wrong by about 20 degrees.
Yeah, but in the other colored spreadsheets, the S value is like 117 something.
So this is 97. This is 97. And
then the red, I think, is the 117.
okay, this one is wrong, and why is this one wrong? Okay,
We
that's an
probably just missed it.
average. Oh, and this is probably wrong because, oh no, I don't know why.
No,
I'll have to look into why.
it's S66 on the red. At cell S66 is showing different than the other colors. I don't know if that's supposed to be. I'm just letting you know. So that is like 97 on the other ones or something.
So it looks like what Jesse gave me as the initial bearing is actually the final bearing because this is lining up pretty darn close to that.
Well, look at the other color spreadsheets real quick at that same exact cell. It's a different number in
Right.
that cell.
And that's a different number. Why? And that's a different number because it's a different location. But is there more to it than that? Let me see. I'm gonna line these up. So we've got 51, 8, 12. Oh, that's not right. Oh, let's. Oh, I see what's wrong. This is still set to 4, so we'll set that to 6, and that brought that to 117,
Nice.
and we'll set this to 6.
Good job, Mike.
And that
That was
brought,
a good catch.
and then so something still wonked out, but we're approaching reality. I think now this is showing a pretty big deviation on the delta between what we measure and what we expect everywhere. And especially bad on the green one. So
If you
let's
go to
look at
that
what's.
cell, if you go to the green cell, did you just make sure that the formula copy correct? Like the U68. That
Okay, so that's obviously wrong. T54 should be T66.
that looks much better, at least.
That looks better. This doesn't look any better. But let me see. F55 should be
55. Yep.
F67.
There we go. We're getting there.
And let's see what this one has for that. This one already had 67. And where was that? B. And this one already has 67. Okay. So still showing pretty good delta. All of them are still showing pretty good deltas. But the delta, let me see. There we go, 54. And instead of 54, it should be 66. So here, instead of 50, oh, this should be 66. And this should be 66. All right, now we're getting really, really close.
Yes.
So the green has still got some kind of radical problem. Ah, there it is. 55 should be 67. Let me see. This is F60. So that's hard to believe. There's only a 6-meter discrepancy between flat Earth and globe Earth. This is not going to be a remarkable proof of anything.
Well,
And
I
I
think the
think that
red. I think there might still be something wrong with the red. If you go back to the graph, Dr. Mike, it looked like the red dipped a little
okay.
at the very end, like on the actual graph part.
Oh yeah,
See how it
yeah.
dips at the
It
end?
does dip a little, and let me see. It has no timing correction yet, but we can't do a timing correction until green is right because we correct it by making the green bearing correct. And when we make the green bearing correct, it straightens everything else out. And so we're still
Okay.
pretty far off. Well, actually, that's showing the green bearing isn't that far off. Oh, but I already know this is the initial bearing, not the final bearing. So we're going to need to figure out what the actual bearing is.
So I got those for you. I was calculating. I have the exact initial and final bearing calculated with the proper geodetic calculator.
Okay.
Would you like
Which
them
one do you want to
in
give me first? Give me the
whichever?
initial first because I'm there.
Okay.
You
Would
told
you
me
like it
before
in
it was one.
Would you like it in DMS or in just decimal degrees?
Um, I prefer decimal degrees.
Okay, so 117 point
Okay.
384
384
52
52
78.
and 8.
And then,
Okay.
ready for the final?
Hold on. Okay, and go ahead and give me the final.
117 dot
Okay.
444, a triple four basically,
Okay.
a 6,
All right.
and then a triple 3, 333.
Okay.
That's it.
See, that was column T. Column T. All right. And so the green line is still off.
I think those might be formatted incorrectly. Did you just copy and paste the T66 and 67 to make them the same?
Yes.
Because it looks like one showing the decimal and the other one, like the bottom cell of those two, converted it into degrees. I don't know
Right.
if that makes a difference, but
That, well, that's what these are supposed to be. It's supposed to be decimal on top, degree, minute, second on the bottom.
okay. And then the green, where it says average, to the right, two cells to your right. Let's look at that formula real quick.
Okay.
Yeah.
Well, that average is correct. The average of one is 1637.1.
Okay, and that's pulling that from V68. Okay, so that's just kind of a average of itself there. So where does
Yeah,
that
this is
number come from, though? Is that okay? Go to the cell above it real quick.
that comes from this. It's
What
just
about
the
what
average of
about
one occlusion.
what about two cells above? Is that just
Okay,
an
2
entry
cells
cell?
above is the
Yeah.
calculated globe Earth value, so it's not very different. So
Are those numbers correct? The cell numbers in that formula?
yeah, they're
Something
correct. It
seems
looks like
off with
this
that
is
number.
okay. Here's a problem. Um,
Oof.
B55 should be B67. That still looks wrong. Let me see. Oh, okay. X is wrong also. So X instead of being 54 should be 66. And X,
I think that's looking wrong because I swear there's got to be something wrong with cell V66. V66 is
B6,
throwing me off for some reason. Yeah. Are all those right at the top there? Is there any numbers wrong in that formula? Because something feels off with that number.
I see nothing wrong with that number.
That is so interesting. Wow. Yeah, I'm at a loss here. I don't know why it's such a big
So
discrepancy.
that's not any kind of discrepancy. That's calculating the rise of that peak above the observer. And it's and keep in mind this is in globe Earth terms. But it's doing that calculation correctly. It's doing this correctly. It's finding only a 12-meter difference, so that's great. So that's like the closest we've come so far, and that's because we're so darn close to that peak. It this refraction calculation doesn't look like that bad. We have a very odd dip in globe Earth. I mean, sorry, flat Earth. Thinking something is probably still wrong here. So that looks good. Oh, wait a minute.
Or like you said, the
This was not.
distances are smaller, you know?
Yeah, the
Yeah.
distances are smaller, and this is only a 6-meter difference. Oh, but we have not made a timing adjustment to this, and oh, the bearing is 4 degrees off. So let's try to put that. This is not the right way to do this. I should measure it on the screen and find out how far off that is. But just for purposes of argument, we'll try to guess at what this is. So
So the initial bearing and the azimuth in stellarium are within 2 arc seconds of angle.
yep. So right now I've got the initial bearing is still almost an arc minute high. Um,
Can I see?
and
Now the
so,
flat Earth
oops.
little line at the end shifted the opposite way now. Interesting.
So 30, 32, 33. We're just going to assume for the moment. So 33 is as close as we can get these two values to perfection. And when we do that, flat Earth is still high. And we'll have to look into why. And so actually, one obvious reason why, like I said, this was an estimate, um, uh, assuming that star was occluded dead center on the peak, which is probably not true. So we'd have to actually make measurements, see where it is,
Hey, Dr. Mike?
and uh-huh.
It was occluded in a slope between 2 peaks. But I found the location on Google Earth where it occluded and got the lat lon for the actual point of occlusion as best as I could. if you want.
So the lat one won't help us, but the bearing would. So if you can figure out how many degrees off it is.
Well, that's the bearing
that,
I gave you was the bearing to the actual point of occlusion.
This bearing?
Let me compare that. Keep highlight it and let me compare it to what I have here. Is that initial bearing?
That is initial bearing, yes, sir.
Okay, initial bearing 117.23. Oh, that's no. The initial bearing is 117 and 23 arc minutes and 4.3 arc seconds.
So that's what you gave me as final bearing.
Oh, earlier?
Yep.
Oh, okay. So earlier I gave you a movable types result, and that's often several arc minutes off because it doesn't use the full proper geodetic math. It just assumes a perfect sphere and I'm not sure what all. So, but
Okay,
eventually
let's try to make this 23.
Eventually the geodesic NOAA one loaded, and I did use that, and so I have the accurate forward or initial and final bearings.
Okay, give me the initial in decimal, please.
Okay. All right. Initial azimuth angle, as calculated by the NOAA, is 117 dot 384
384
52
52
78.
78, and let me copy that to the next sheet before I forget. All right, and now the final bearing.
And the final bearing is 117 dot.
Okay.
444.
Okay.
And then 6. And then 333.
Okay. All right.
That's it.
Okay, so this is 4 degrees off. So let's see if we can put that on. That is pretty darn close, 2-second offset. And so for some reason our peak is still a little low, and it's copied that okay. Well, we'll have to look into this. Why? Since that has never happened before. Oh, and you said, if I understood you correctly, you said you verified that this star actually included dead center on the initial bearing. So in other words, it hit the peak dead center.
Not the peak, but the middle slope. So you might have to change the elevation to match that slope portion.
Let me try something. Often you can set this globe, you can adjust it so the globe says to 0 and it will be right on. That's what normally happens. So let me see, is 27 closer? Nope, 20. So that's probably as close as we'll get. And it's still showing a deviation. In fact, it made the flat Earth deviation worse. Oh,
you know what?
But I forgot to.
I just remembered how I got the coordinate. I found the lat lon on Google Earth, which gave the gave an azimuth angle that matched the azimuth angle given by Stellarium. So you probably need to just go back and try to derive where it actually hit the peak. Although I don't think there's any known way to do that because there was no recognizable peak in the video.
So you got any idea, Alan, how whether it actually where it might have hit on that peak?
Yeah, it hit on the slope coming off of the right side of it.
The right, that would tend to be a higher number. So let me go higher.
At the risk of sounding absolutely ridiculous, we're not conflating the peak from earlier that Jesse showed in his video with this houndstooth peak, right?
My video was not
It was
houndstooth.
yeah,
I
his video
know.
was north
I'm
peak, and his video was at 200 degrees in about 40 arc minutes or so. So this is yeah, there's no possibility that this is being
yeah.
mistaken.
My question was more so we're not thinking about how that peak went down a little bit, like Jesse was saying. We're not conflating that with this observation, like just not thinking about it,
So
right? Like this
so
also had a weird.
literally, just so this is perfectly clear to everybody, literally none of that matters. The only thing matters is that you correctly figure out where that star occluded relative to um, the azimuth, the initial bearing to dead center on the peak. You want to know how far off that star actually occluded relative to dead center on the peak.
Dr. Heffron, if you look in the live stream chat, I put an overlay picture where I overlaid a screenshot from Alan's video onto Stellarium to kind of give you an idea roughly where the sea star was pointed.
Is this on Earth Awakenings chat or
Yes. I tried to DM stuff to you, but you have to accept my friend request first. Discord won't let me DM you unless you accept my friend request.
and I don't see a friend request, but
don't worry about
keep
that
in
right
mind
now.
that I'm not good at this. So is there any way you can make an estimate of how far off from the peak that was? Because that's what's important here. Is we want to get this number to reflect how far off was it from dead center on the peak.
I don't know of any way to do that accurately.
So the
Do you
way I
guys
do it
want
is
to
put a
try?
ruler on the screen.
Do you guys want to try Squamish? Like Squamish at the peaks, dead on. I don't know how much more work that would be, but I think Jesse's got all the numbers.
Oh, I have all the numbers. Unfortunately, they're in feet and miles.
Oh,
But
you put them into keep things in meters, man.
I can convert them. I can
Okay.
convert them.
Yeah, it's cool. Just meters are.
Yeah,
I don't know.
unfortunately.
I don't know. Maybe we walked too far down this path, but
unfortunately, Dr. Heffron, the no peak or no identifiable landmark appeared in the frame of the sea star to actually know what the physical azimuth was.
So that's always a problem if you can't see your peak well enough to make that estimate. That's one of the reasons I use 1 second exposures. So the peak is very, very clear and it's really easy to make measurements relative to that peak. It's really easy to tell how far offset it was. And so it's kind of a pain in a way, but if you're using a C-Star S50 like I was, I recommend maximum gain, 1 second exposures, 1 second time lapse, and then you can see the peak really, really well. And if you get it centered on the peak before you start, then you have a good indication the peak is pretty close to center, which is 22 arc seconds in. So I personally I try to do that, but the ruler trick works pretty darn well. Well, let me see.
Oh, Goose got a really good observation. Didn't that one set right into the tippy top of a point?
Yeah,
Goose?
it nailed. Yeah, it nailed the peak. Like absolutely nailed it. It's crazy. It's crazy how much it nailed it. But yeah.
Yeah, if it would be easier because you have all the stuff to just send gooses real quick, let's do that. And then if we could wrap this up in like the next 5-10 minutes, that would be super dope. Sorry for having this
Oh,
drag out forever.
okay, if you notice what I just did here,
Oh, there we go.
sorry I was being very, very quiet about this, but I noticed that I'm expecting the globe dip to be 6.1. I just adjusted the timing offset so that the negative globe dip is 6.1. And when I do that, here's the graph. Flat Earth right, um, globe Earth uncorrected is almost identical to flat Earth, and then globe Earth with refraction on is 100 and some meters high. Or if I turn off, it seems to be matching the green line. Turn refraction completely off, it's way high, so that's all a little weird. But refraction often skews something way high or way low, as we see with all these other peaks. So I'm not real concerned about that. And the negative 6 meters is barely noticeable on this. That's a good reason to stay away from peaks that are that close, because enough difference to distinguish between flat Earth and globe Earth. But I think we finally got it dialed in pretty close, and this shows that it was 2 arc minutes and 19 arc seconds to the right of dead center on the peak. And that's assuming that any of this is correct.
I
And
think it
so
makes a lot of
I would
sense
like to double check in.
when you pointed out the fact that the distance wasn't nearly as much as the others. It does make sense. I mean, there's a lot less Earth curve, right? If we're looking at it from a globe standpoint. So
Yeah,
it
we're
kind of
literally looking at
makes sense.
6.1 meters. Yeah, 6.1 meters of Earth curve is almost non-existent. And you compare it to the Earth curve on all these others, it's like the least Earth curve of all the peaks so far. All the rest have had
Which makes total sense,
100 meters.
Yeah, yeah. I mean, it makes a lot of sense. It's interesting.
And so all these numbers on this spreadsheet will have to be double checked, and I can download this to an XLS, and then I will go ahead and I don't know how to put this in Earth Awakenings chat, but I'll put it in Ether Cosmology main chat, and so I'll upload that from my downloads. There we go. And I'll just say here's the spreadsheet we just built together.
I'll grab it and repost it.
Thank you.
That's awesome.
And in a couple seconds, oh, oops, was I hot miking? I will have meters and meters for Goose's location.
Real quick, how many celestial theodolite observations total do you guys have right now? roughly?
In the 40s.
In the 40s? Someone else in chat.
I reposted it.
All right, I have.
Yeah, there's 46 on this spreadsheet.
46? Thank you.
46 on this spreadsheet.
And there's more easily identifiable stars in the videos that we haven't even cataloged yet. But I have Goose's very nice data already in meters and decimal longitude and latitudes, if you would like to try that. But I don't know if we got time left.
Nice. And then, sorry this was so painful, Alan. I didn't expect this live. Adding a star would be so complicated, but as you can see, all the numbers have to be perfect to make it work. So I always copy and paste from the peak above and this, and I go through and look for all the things that were direct references to the altitude and distance and observer altitude and all that from the one above. And I go through and fix those first before I start adding stars. And so that was probably the mistake I made here. I wasn't thorough enough in making sure I had all those things I copied from above corrected properly. So I guess this is the word to the wise. Double check all that before you start adding stars.
Yeah, live tech demos kind of go this way a lot too. So it's kind of par for the course on this kind of stuff. Doing it all live.
Yep.
Can you click on? Well, I noticed you change your seconds offset, and it automatically changes the azimuths. Are you emulating what Stellarium would do by changing the time there to save having to look it up in Stellarium?
Yep, it's exactly what it's doing. It's
cool.
it's not perfect, but it's extremely close to Stellarium. In fact, so close you can't really tell the difference.
Okay.
Yeah, it seems like you back engineered what they actually do, in my opinion.
Yep, that was my goal, and I was like overjoyed when I accomplished my goal. So slide 11 shows the equations they're using, and they're not using G.G. Bennett's refraction, but they're using something that's so close you can hardly tell the difference.
I'm off to bed, guys. I respect that you can go for 4 hours, but I gotta get rest. Good night, everybody. Thank you for the presentation.
Good night.
Good.
Thank you, Kelly. Thank you, Beast. Thank you, Regis, for helping out. Everyone that's Goose, everyone that's been helping out, Jesse. You guys have been great.
Yeah,
for hosting
and
everything.
Jesse, I'm sorry.
Thanks for the Prezi. Awesome work.
I'm sorry you and I have had so many miscommunications, Jesse, and that I ramble too much.
No,
but hopefully we're getting
Dr. Mike, you're
closer
good.
to an understanding.
Yeah, no, Dr. Mike, you're good. We appreciate your time very much, Dr. Mike.
You did 4 hours with us, Dr. Mike. Ooh,
This
those
is
dogs
amazing
are
work.
hungry.
This is amazing work. Like, to be clear, we're just refining this. We're not. It's not hard to tell globe and flat with this celestial theodolite. Like, there's a pretty remarkable deviation. So,
I got to be honest. When
So
we first
fortunately, my wife
saw
jumped
this,
in and took care of the dogs.
when I first saw this, Dr. Mike, it was amazing. I didn't know how it would extrapolate to other observations. So I am very, very happy to see this. This is amazing stuff, and I thank you for your time.
Awesome.
Yep, it's been interesting. And then I did that intro Prezi at the very beginning because it's easy to lose track of the concepts as we discuss things and people weigh in with their opinions. So if you had any doubt what I originally proposed and how we got to where we are now, that intro Prezi is a real good description of how we went from the initial concept to where we are now.
I have no doubts at all. And I'm still going to check that out, though, because I really want to see it. Thanks again, man. And everybody, good night.
Good night, everyone. And a special shout out to everyone who bought Ether Cause merch. We use that, the profits from that and the lifetime memberships to buy that Sea Star. So without your guys' contributions, this this wouldn't even be possible. So special shout out to all the Ether Cause lifetime members.
Shout out.
For sure.
All right. No, let's see. What have we got coming up? Tomorrow will be a presentation on Ether Cause. We're doing of the YouTube video from a YouTube channel called Inductica. He just did a recent video on ether mechanics and wave mechanics. So we're going to take a review of that. So that'll be at 8 p.m. Eastern, 5 p.m. Pacific.
Yay.
Now we disconnect Shane.